marine engineer out in Bellingham, Washington, who's a supporter of that. And then there is the Tesla version, which is what he called an earthquake machine.
Yes, so this was a fascinating part of your book. I had no clue.
Electromechanical device that sends time pulses into a structure, whether it's a beam on a bridge or an I-beam in a building in New York, which I think there's reports that he did that and almost brought the building down.
Yeah, there was a story. You told a story in your book.
Right.
The story was fascinating. They were in the basement of a huge building in New York, and they turned on the generator, and the building started falling down around them. For all the time that we have been alive, the U.S. dollar has been the primary currency, but that may not be the case for much longer. China is set to dethrone the dollar, and possibly much sooner than you think. And even the world's biggest wave force in the reviewers in 326 for concrete.
I don't when you can say
532. Now back to the show.
Right. Well, I don't think anything fell off, but he was threatening to. He had to break the machine. I don't think he
smashed it with a hammer, right?
And got the hell out of there. Yeah.
God.
Well, resonance is a really powerful force when you consider it. When you impart energy into a system that is already has a certain amount of energy and is vibrating of a particular frequency, and you catch it at a node, right, a high node. An example would be a pendulum or a swinging ball. Okay, so the swinging ball comes back to you, it reaches the arc height, and then you apply energy right there, then put energy into it, and you go further. And so you can start out very, very small movements of this. Could be a ton, maybe you just move it an inch, and then it swings back to you, and you give it the same amount of force, and it moves 2 inches, and then comes back to you, and you step back, and each time you're stepping back, and by the time, you can build up quite a swing on that ball without, going up to it and having to smack it with a hammer. Probably break the hammer, but the point is that a small child could create quite an effect just by using resonance, and then the whole idea of accumulated energy.
What was the purpose of Tesla's earthquake machine? What was he trying to accomplish with
that? He actually believed and wrote that he thought that you could relieve earthquakes or the severity of earthquakes in the earth. And it was interesting. That was reported. I hadn't read that when I wrote the Giza Power Plant, because I had made that observation in the Giza Power Plant that perhaps with a system for drawing energy out of the earth, one of the effects of that would be the energy that is accumulating in the Earth's plates, where they push together to the point of breaking, or rapid release, where you have seismic waves moving out.
So going around with this machine and basically creating little mini earthquakes to avoid some big earthquake down the line.
Yes.
Okay.
Yes.
Okay. Interesting.
Yeah, that was one of his ideas about the use of his machine.
Okay.
So basically, that was in alignment with what I was thinking.
Okay. And you imagine something like this was down there in the subterranean chamber?
Yeah.
Okay.
Possibly. Yeah.
Okay.
I think everything is open to further research and input from other specialists. I mean, obviously, if you're going to start playing around with the planet, you're going to have to have geophysicists involved, geologists involved, seismologists involved. You can't just willy-nilly go in there and start putting vibrations into the earth in a great quantity. I don't know.
Yeah, it'd be dangerous.
I don't know. I mean, it's like you have to be, I think, fully aware of what the outcomes are going to be.
Yes.
The positive and the negative. They say, okay, free energy. Is there such a thing as free energy? Well, the energy is there. It's free. Just go get it. But it's going to cost you to get it. And then it may cost you to clean up after you get it. It's just like the nuclear energy, fossil fuel energy. All that. There's always a cost associated. Right. But the thing with the electron house, and the most significant discovery was made by Friedemann Freund, Dr. Friedemann Freund.
Who is he?
Friedemann Freund, he's a physicist, works at NASA, and he was studying earthquake lights. And his objective was to determine if, by monitoring the Earth at these seismic hotspots, if earthquake lights could actually be an early warning system for impending earthquakes. And so he was studying the earthquake lights of different areas around the world.
Okay.
And there was one particular place that it became apparent that there was an earthquake coming, and that was in Italy. It was called the Aquila earthquake. But his discovery is really I think the most important discovery in this century, or the last century, because you have a source of electrons that's directly under our feet. And so what I tried to do in Giza, the Tesla solution, was to highlight the idea that we have been making advances in semiconductor physics, transistors and things of that nature. We make a quantum leaps in understanding the function of devices that control the way electrons behave within a particular device, like a cell phone or a laptop, something like that. Right. All of those are amazing advances. Right? All those electrons are coming through wires and generated, for the most part, from traditional power plants that are operating principally the same way they have for over 100 years.
Right.
And so they basically boil water, create steam, plus turbine blades, rotate generators, and harvest the electrons, and then put it in, transmit it into the grid.
Okay.
Here, it's to recognize that all those electrons that you want are actually under your feet. And there are some areas of the world, in the country, that are more active in terms of earthquake lights than others, and certain areas that are more seismically unstable. And so, the question is, should a serious study be funded or followed to investigate whether we can actually access those electrons directly and use them rather than going through the process of extraction of fossil fuels, burning, all the ancillary costs that you have, transportation and stuff like that, pollution. But here you have a battery under your feet. Why? To re-tap into it and draw that energy out. So what does Dr. Freund do about his theory? He studied the effects. He studied in his laboratory how to generate electron flow in different types of rocks, igneous rocks, like granite.
What is the meaning of igneous rocks? What does that mean?
It means it was formed as magma in the earth, as opposed to sedimentary rocks.
Okay, got it.
So the igneous rocks are basically they contain these peroxy defaults in the minerals, and when they are stressed or pressure is put on them, they will migrate to the surface very rapidly. And he's demonstrated in his lab that he can take a granite block or beam of granite, he put it in a hydraulic press, equipped it with electrodes and a monitor, oscilloscope, put pressure on one end, squeezed it, and electrons flow from one pole to the other, one end to the other.
Wow.
And he was able to measure.
That's an explanation for the earthquake lights. This is happening deep inside the earth,
Right.
near
Exactly.
near these seismic areas where there's fault lines and stuff like that. And when these giant rocks are being crammed together, these electrons are being released and they shoot out through the rock, up through the surface of the earth and into the sky.
Yeah. You want to show a YouTube video?
Yes. Which video should we show?
It's on YouTube.
Okay, what's it called?
It's Friedman Freund, and his TED Talk in Christchurch, New Zealand.
Okay. Friedman Freund, TED Talk in Christchurch, New Zealand. Okay, is that Dr. Friedman?
That's Dr. Friedman. Yeah.
Okay.
He's up in his 80s now. He's a wonderful guy.
Came to Christchurch to talk about earthquakes. There's no better place in the world, say, to talk about earthquakes. In particular, I want to give you hope. So, if we look at the photo of the New Zealand island, it looks so peaceful and placid. You see Christchurch on the left side. But on certain days, occasionally, the earth speaks to us with a very violent voice. And many of you have gone through this experience. I would like to present you with the question, what if we would be able to see these earthquakes coming days before they arrive? Now, I worked for the past 30 years at NASA in California. Before this, I was a professor in Germany. And during that time, I was doing things that had no relationship
That was an
with
Operation Paperclip, was it?
earthquakes. I was studying single crystals. I started out working on very, very simple single crystals, totally, as I said, unrelated, never dreaming that what I would be working on could one day have influence and importance for understanding earthquakes. Magnesium oxide, the simplest oxide material that exists. And I worked on it for a number of years. And I discovered something that everybody else had overlooked, had missed. And that is a defect, a type of defect in these crystals. And I should say a defect in our word of solid-state physics is something that occurs, it's not a crack, it is something on the atomic, on the subatomic. What I discovered was that in the crystal structure, like here on the lower left side, there are these defects that are totally invisible. Still now we have no way how to directly observe these peroxy defects. But when we do nasty things to the crystal, they fall apart and produce electric charge carriers. Then I found the same kind of defects in other materials, including natural minerals, either from the crust or from the earth mantle. Almost every mineral seems to have these. And if minerals have them, then of course rocks will have them. So now I want to show you what you can do when you play around with rocks. So here, you see
wow.
a 4-meter long piece of granite in my laboratory at NASA Ames. And all what I'm doing here is I put some contacts to the rock at the far end and a contact up here, and I squeeze here. In the moment I start squeezing here, a current starts to flow through the unstressed rock. And if I put an ammeter, picoammeter in the circuit, I can measure an electric current. And here you see this example measured from this particular 4-meter long piece of granite. In the moment, the green curve is the load. The moment I start to load the rock, the current begins to flow. The current rises very, very rapidly at low stress levels, saturates, stays constant. Actually, we have measured this over a month. The current continues to flow if we keep it loaded. This is a behavior that is reminiscent of semiconductor, the things from which you build transistors and hence available in all electronics. Here at the bottom, you see a schematic on the right-hand side. Stress activates electrons and holes. Holes is a name for the defect electrons. These are electronic particles that are generated and that are actually necessary to be able to produce a transistor. And we found out that the electrons have to stay in the stress rock volume while the holes get flow out. They flow out at about 100 meters per second, which is about the speed of a jet landing in an airport. They're very fast. They propagate through it, and in this particular experiment, the electrons have to come around through the wire and shake hands at the front end of this rock. Now, this is a combination of the semiconductor behavior, formation of electrons and holes, and of an electrochemical battery. That means we can separate the positive holes flowing through the rock from the negative holes that flow through the wire. This is exciting, and this is new. So now let's do a Duncan experiment. Take this rock and imagine that it would be sitting vertically in the Earth's crust. And that this rock is not 4 meters long, but a kilometer, 5 kilometers, 10 kilometers long, 30, 50, 100 kilometers long, if we are in a subduction zone like you have it here on the North Island. If that end of that volume of rock is being stressed by the enormous tectonic forces in the Earth, electricity is generated, and under certain conditions, this electricity flows out of the stressed rock volume and into the surrounding rock. And we have means to see these things flowing over a distance of tens of kilometers under natural conditions. These are amazing processes that have never before been properly understood. So all these things we can now use to learn something about the stress state of rocks deep below our feet, far beyond the direct reach, we have to deduce medium presence from these infrared measurements. We can establish these causality ranges linked together by chemistry and by physics. So I wanted to briefly mention this infrared emission. The infrared emission is when the charge carriers come to the surface and can recombine. During this recombination, these charge carriers release energy, and these two oxygens that you show there up, they become suddenly about 20,000 degrees hot vibrationally, and they emit bursts of infrared radiation. But one characteristic feature that these charge carriers try to accumulate mostly on mountaintops, on hillsides, not in the valley. So now I want to show you here a result from a PhD physicist, Luca Pierotti in Italy, who had analyzed, I think, 18 months of Italy. Every night he looked for these anomalies, and prior to this earthquake in L'Aquila in 2009, he identified this anomaly that you see here in red, with a loss of life of more than 300 people. And to the left and to the right, there are mountain ranges. The one that Cansasso are the highest mountains in the middle of Italy. And in the next slide, you will see draped over exactly the same these map of the thermal infrared anomalies as they are measured 3 days before that disastrous earthquake. So if anybody would have had funding, the knowledge to analyze and how important the analysis is of these phenomena in real time, 3 days before the earthquake, they would have issued the warning that something is brewing, something must be happening 10, 20 kilometers below our feet. Now, next I want to talk about these unipolar pulses. Unipolar pulses are strange phenomena that suddenly, within a fraction of a second, enormous energy, electromagnetic energy, is emitted from deep below, only about 100, 150, 200 milliseconds long, shoots up and comes down with a little wiggle and disappears. They're not yet fully understood. We're working on it. Now here, a situation where a friend of mine, colleague, Jorge Hero, has operated for the past 2.5 years, a station consisting of 2 search coil magnetometers, extremely sensitive. And what you see there is in the subduction zone, there is a ridge, a submarine ridge. That's where earthquakes are being generated. That ridge is subducted and disappears underneath the edge of the South American continent. Now here is, I think it is running. So here again the map, and you will see in a moment how these unipolar pulses are generated. And they are marked here by, this is a period of about 2 weeks that you see displayed. And here they come. A few 10 minutes distance from each other in groups. Then there is a day and a half of silence, no unipolar pulse. The next group is coming, again, a little silent, or there is another blip from somewhere far away. And then there's a third group of these pulses coming. By now we have 2,500, more than 2,500 of these pulses, and they were associated with 22 magnitude 4 earthquakes, 3.5 to 4 earthquakes that happened in this subduction zone between the depths of 25 to 65 kilometers. And they were, Jorge Hero is able to predict a time window of 40 hours, 3 to 6 days in advance, depositing the information in a closed envelope with the president of his university. And in all 22 cases that he has analyzed, he was right. This is quite remarkable.
Wow.
Can we come to the next slide, please? It doesn't. Oh, yeah. So I've started my presentation with asking what if we can see earthquakes coming. And I think I can say, I've convinced you that by understanding the physics, and this is really new physics, of how rocks respond deep below to the increase of stress, and what they are producing electricity, and how this electricity propagates through the Earth's crust, we can learn about the buildup of stress, and we will be able to say, yes, we can see them coming days before they will arrive. We cannot be sure that every stress buildup will lead to an earthquake, because sometimes the Earth says, I don't feel like rupturing, I feel like sliding. And we see the precursors, and people would say you have had a false alarm. No, we have not had a false alarm. The Earth just had another day, another feeling. But in most cases, one thing we can make for sure, in the future, there will be no major earthquake that will hit any place in the world where we have the capability of measuring these precursory signals, will hit unannounced, unforewarned. Wow. Well, the element of utter surprise that has been a plague until recently, including the Christchurch earthquakes, will be over. Thank you so much.
Is anybody using this stuff to detect earthquakes now?
No, that's another story altogether. The seismologists are pretty much ignoring it from what I can understand.
Why are they ignoring this?
They prefer the traditional mechanical ways of detecting earthquakes.
That's bizarre that all the mountain ranges surrounding that
Right.
city were lit up
Yeah, I know.
by the earthquake lights, right?
Yeah, right.
And that's exactly analogous to what would have happened within the pyramid with those vibrations shooting up through those giant pile of rocks that they built in the desert.
Exactly right.
So the pyramid would have glowed similar.
Yeah, I believe so. The yeah, I mean, there has been an electrical phenomenon detected in the pyramids anyway. I mean, as far as people noticing, like tingling. There was one story about a William Siemens who was climbing the pyramid with a guide, and he detected a ringing in his ear, and, a little buzzing on his finger. He fashioned what they call a Leyden jar, which is kind of an accumulator of an electrical charge. He accumulated a charge,
Yeah.
and the guide who was kind of following him, I think, thought he was practicing witchcraft or whatever, and so he just held out the jar and shocked the guard. The guide went howling down the side of the pyramid. He was so that's one of the anecdotal stories that you get. And I mean, that's rough.
So how did you and Freeman Freud connect?
So I had on my 2018 Lost Technologies tour in Egypt, I had some really brilliant minds with me. One of them is Robert Volta, who is a sound engineer.
Okay.
And and there was a geologist there. There was a
He looked like a sound engineer.
yeah, he's a front of house sound engineer, total roadie.
Yeah.
Super geek.
Yeah, he looked like a sound guy. Right, Steve?
He's also got a degree in archaeology.
Oh, does he really? Oh, wow. Good for him.
That's beside the point. That's the least of his shames. But no, and so I connected with Robert actually when I was writing the Giza power plant, because
Okay.
an aspect to the function of sound within the pyramid, and I had been told about Robert by a gentleman called Stephen Mailer, who was a friend of his at the time. So I called him up and I just asked him a few questions. And he, yeah, obviously, yeah. Talked about, the harmonics in Great Pyramid and other pyramids. So in like 2016, we lost contact. We lost touch for quite a while. 2016, I called him, and basically at that time I was pondering on writing another book, right? Because a lot had happened since the first book, and people were bugging me. When are you going to write it? When are you going to update the Giza Power Plant? I was like, maybe never. I don't know. But I really didn't think I had enough material to do a full book. It may have been a new edition of the Giza Power Plant. And so I went out to visit with him and spent some time with him chatting. We arranged to do the tour in 2018. Eric Wilson, who's an aerospace engineer, he came along. Adrian Lundgren, who was a geologist, he came along. There was entrepreneurs, there was other engineers, a lot of technical type people who signed up. But it was basically just focused on technology. There was no other subject matter. Anyway, so while we were there, we were talking about the role that piezoelectricity plays in the production of electron flow in the granite, in the King's Chamber. And Adrian Lundgren, who said, well, it's recorded in some books that it's 55% of the granite is quartz crystal, silicon quartz crystal. In order for the piezoelectric effect to work, the quartz crystal has to be stressed across a particular axis, otherwise it doesn't work. And because of the random orientation of the quartz in the granite, it was seen to not be a very efficient way to generate electricity. Also, as a geologist, Adrian suggested that the amount of quartz in the granite was a lot less than what has been discussed in the past.
Yeah,
well,
initially you thought it was like 80 to 90%. And
initially it was 55%.
Okay.
That's what I wrote in the Giza Power Plant, based on what I had read in other books.
Okay.
And then he said it may be more like 20%, maybe less than that. Okay. So that kind of shot the piezoelectric aspect out of the water.
Okay.
And but I was like, there has to be something out. There has to be something else, right? And so Robert was just doing. He lives in San Jose, California, in the foothills overlooking Silicon Valley, right? Mm-hmm. And so he's poking around doing some research on granite and minerals and piezoelectricity. And then one of his searches, he came up with Friedman Freund and started to look at his stuff.
Okay.
Right. And so then he called Friedman up and they arranged to meet. And he went into NASA to meet with him and gave a presentation to the whole NASA group. And it was all about the pyramids and the energetic purpose for the pyramids and the resonance and acoustics of the pyramids. Also the very, very fine manufacturing machining of the parts that go into it.
And he presented all this stuff in front of a bunch of NASA scientists?
Yeah.
What was the reception he got from them?
They're fascinated. I mean, I talked to them too. They had a group. It's called the Geocosmos Group. It's not a NASA group, but it is a think tank that Friedman kind of formed to study planetary issues. Phenomena like earthquake flags and other subjects. But this group is comprised of scientists from all over the world, and so Robert was invited to join that group. And then when I started to get into writing the Giza Power 2, or the Tesla Connection, as it finally became known, I actually reached out to Friedman because I was trying to come to grasp with his research. Because if you read his scientific papers, they're heavily involved with. There's a lot of math to it, obviously, and so most of that was above my head. But as you saw in that little video, he was talking to lay people and presenting his theory to lay people in general terms. Even though there were formulas in some of his slides, he was not speaking, above their head. You know what I mean?
Yes. So is he completely on board with your theory?
He supports me. I think as a person, I've never directly asked him if he supports what I'm doing. There's an appendix in my book that is a transcript of that Christchurch lecture, and so I got permission from him to include it in my book, and he actually went through it and edited it for clarity.
Is that something you think he has to worry about, sort of like backing up your theory, being somebody who's employed by NASA? You think he might be labeled as like a kook or something if he started saying that the pyramid was a power plant?
Yeah, he probably would be. I mean, that is normally people's reaction, but that's not like a typical reaction. Mm-hmm. But the thing is with most physicists, and there are other physicists that I've communicated with, is that when politics doesn't enter into their minds when they are studying nature and trying to find answers to particular problems or phenomena. Politics of it is something they have to deal with later. So it's like, they're just going to go ahead and call it like they see it, and then whatever the politics flow from that. I mean, it's just like anybody, Einstein or Oppenheimer or anybody who is breaking new ground and is thinking. Mm-hmm. Eventually they're going to be faced with the politics of what their creations become.
Yeah, and there's going to be a lot of politics around something like this. I mean, the implications of this idea are something that could change the future of humanity, the future of the human race. Like, if we could figure out how to power our civilization through using the Earth as a battery and using these rocks to generate electrons and have free energy, I mean,
yeah, or at least
that's not a small idea.
No, it's not a small idea. It's a and it's not, and it doesn't come at a small price tag either. It's like, I mean, there's
compared to what?
Yeah, exactly. That is a brilliant question because it's loaded. It's a loaded question compared to what you name it, compared to environmental controls, compared to the amount of coal that's in the earth now, the amount that we burn every year, compared to all the maintenance and ancillary activity that surrounds the creation of electricity that we're creating now. Maintenance, oh my God, I mean, you're talking about millions, billions of dollars.
How much you estimate exactly how much it would cost to actually go out there, take all the scientists out to the Great Pyramid, restore it, and actually test it against your theory to see if it works the way you think it works?
No, I did not. No, I wouldn't even dare. Are you kidding me? I mean, yeah, I may have balls, but they're not that big. I don't have the gravitas to do something like that. So in my book,
Didn't you estimate it?
No. There was an estimator who his job is to do cost estimations for building power plants.
Okay.
So he emailed me, and he laid out a quote for what it would cost to create the Great Pyramid, assuming that it would produce like 25 gigawatts of power. And
25 gigawatts.
And he estimated that it would be around $25 billion. But
Where would that money where does that cost go to? What specifically does it take all that money to do?
that's the extraction of the rock,
The rock.
the crafting of it, the transportation of it.
That's just the rocks.
But I think, but I really don't know. I mean, when we talk about building a pyramid today using our technology, the technology that we're familiar with, there was an estimate that was made by the director of the Limestone Institute in Indiana. His name was Merle Bucker. And he was asked for an estimate by Richard Noon, who wrote a book called 552,000. Very unfortunate title, but it was a good book. It had a lot of good information.
552,000?
Yeah, it was a doomsday type of book, right? So
Wait, the Earth, the world's going to end. in 2000?
yeah.
Okay.
Planet alignments, and there'll be a pole shift, and everybody will fly.
Pole shift.
So, but I mean, Richard is a wonderful guy. I met him. He's a great guy, and his book is loaded with information. Anyway, so he had included in his book the estimate that he got from Merle Bucker. And Merle Bucker said that the 33 quarries that they have around Bedford, Indiana, they would, if they tripled their output, to quarry and cut enough stone to build the pyramid, a great pyramid, it would take 27 years just to quarry it and deliver it to the site. That doesn't mean putting it together. They're just delivering the stuff. And that's assuming no equipment breakdowns, no union strife or labor problems or anything like that. Full tripling the output.
Tripling their output.
Of all their quarries.
And that was the cost was what again?
The cost, it did cost down. It would be 27 years.
Okay. The 25 billion was actually complete the pyramid.
Oh, that was an estimate from this estimator in England.
Oh, okay.
So, I mean, that is like, you have, ever since people have studied the Great Pyramid and wrote about it, there have been, I don't know, as many people who have opined about building it. You have that many different ideas of how many people it took and what they would do and, and how they would do it. You've got estimates from 10,000 workers to 100,000 workers, from 20 years to 100 years to build it. It's like there's nothing realistic or factual, really hard factual, that you can assert this is correct until you actually do it and you have some results. So I don't know. I mean, we don't know how the Egyptians did it, and really right now we don't know how we would do it because it's armchair theorists are not going to do it. They're not going to build it. You're going to need professionals who get involved and upgrade just about every technology that they're going to use in order to accomplish it. Whether it's a quarry worker who has to, or a quarry company that has to install precision machinery that will hold tolerances on blocks of limestone to within 10,000 instead of a quarter of it, which they may be currently working. And that's a huge step to take because you have, when you look at craft skills, you go from quarry working to woodworking to metalworking. You've got machining, then within metalworking, you've got machining, you've got tool making, you've got gauge making, and all of those particular craft trades work to different tolerances. And the more zeros you put after a decimal point when it comes to the tolerance on a dimension, the more expensive it is to make because it takes longer to make, and the people who are actually creating it are paid more. So you pay more for a tool maker than, say, a machinist. You pay more for a machinist than, say, a carpenter. It's all about how much you invest in a person and how really adaptable they are to working to within those really, really tight tolerances, really small tolerances.
Yeah, because even like the buildings that you see today, even the skyscrapers, if you were to measure the base of those skyscrapers, they're within, like, if I'm correct, I think they're within a 6-inch degree of tolerance. They can be like the square, they can be 6 inches off square, and they can still build this according to code, like a skyscraper.
Really? Yeah.
I thought I got that from your book, maybe not.
No.
Okay. But like, you correlate the main thing about this precision is like you don't have to have precision without a function. Like the goal of precision is function, right? Like there's no need to make those things, or these blocks, for example, in Serapeum. What's the point of making them that precise unless it's necessary for a function?
Right, exactly. The only other reason why they would be that precise is that they were employing tools and methods that were capable of no less precision. So if you consider the quality of products that are made today, you compare your vehicle that's in the parking lot with a vehicle that came out of Detroit in the 70s, and you look at the fit and finish on the body and the other components in the car, you see a big difference in the tolerance and the precision of those pieces, like the way a door fits and the gap between the two. Right? So the evolution of manufacturing has been to actually eliminate variables in the system or variables in the process that allow for error to exist or to allow for variance to exist. So when you talk about variance, you're talking about anything that varies from a perfect form. So you design a perfect form today in a computer, in the past on the drawing board. This is a perfect form. Make it. Okay. How much can you tolerate from the person who's making it? A variation from that perfect form that you defined.
Right.
Right. That's called the tolerance band. And so that tolerance band has been gradually getting smaller and smaller and smaller over the years. So now, where like cell phones that they make in their millions, the manufacturing process has been perfected such that every one comes up almost perfect.
But one of the big questions, like you even pose in your book, is when it comes to people challenging your idea.
Yeah.
Well, before we talk about that, what sort of response have you gotten from like academia or Egyptologists on your first book, Giza Power Plant? Obviously, you're not out yet, but like, what's been the response from people in general?
It is a radical, revolutionary idea that is totally divorced from what the historical records contain, what their records, what their theories are. And it's deemed to be fringe pseudoscience. So when it comes to explaining certain features of the Great Pyramid, like the shafts, Egyptologists rely on magic.
Yes, I noticed that in that video you sent. I was watching that you referenced in the book when they had a TV show where they were sending that robot up through the shaft, up to Gatenbrake's door to drill through the shaft. And the narrator was like, why would they end the shaft here? Why would they put a door there? And then it would cut to some scholar saying that it's very obvious if you use logic. The reason for that door is because Khufu's soul needed to open the door to reach the heavens, and you need a door. It can't just be a free-flowing opening to the heavens. There needs to be a door that he has to pass through to get to the heavens. It's just logic.
Yes. Well,
I was like, what?
I don't. Yeah, I think you may have embellished that a little bit, Daniel.
No, I didn't. I underplayed that.
You underplayed it.
She literally said, if you use logic. This may not be verbatim, but she did say, if you use logic.
No.
She's talking about souls.
You got the wrong word. It sounds like logic. I mean, it ends in a GIC. It's magic.
Magic. No, but I swear, if you rewatch that, she said logic. She said logically.
No.
She said logically.
Magic. It's magic.
Maybe I didn't hear it right.
You got to pull up those clips. Do we have them? Never mind.
Yeah.
We'll show them after the break.
Yeah. So the point is, these scientists that are being interviewed for this National Geographic video, it's all spiritual and magic. Is there explanations for these things?
Well, yeah. I mean, the explanation for all the shafts, the king is soul can exit the pyramid and go into the heavens, right? And in that documentary, the narrator asked the question, but what about the Queen's Chamber? Why do they need 4 shafts? And why do they have handles? And what about this blockage? And then she says, well, Mark Lehner, who is an American Egyptologist, believes that magic could be a part of it. And so then Mark Lehner opines about, well, the Queen's Chamber is just a dummy chamber, and the soul would have no problem passing through limestone. Right. And that is what they call a false door. So there's magic involved there. And then Rainer Stadelman, who is a German Egyptologist, he's in the King's Chamber, and he answers the question about the handles, or what they call, those metal fittings ahead. And he says that those are magical instruments that the soul uses to lift the door so that he can pass through. So you got one Egyptologist saying, won't have a problem passing through that limestone, and then another one saying, well, you got to have those magical instruments to lift it. And then I'm thinking, is there a soul? Has that been proven? From a scientific perspective? I mean, that has been a long, perennial question in people's mind, the existence of the soul.
Yeah. Have you ever had a conversation with Zahi Hawass about this?
I have met him a few times. And the first time was in 2001. I was supposed to meet him in 1995, but I didn't. In 2001, I was in Egypt filming with Grizzly Adams for the PAX Television, and he was going to be a presenter also during that time. And so after a day of filming, the field producer and I went up to his office, and he was very cordial, very kind.
Cordial.
And which, a very ebullient, charming, charismatic guy. And we asked him, hey, we'd like to visit the Serapeum. We'd also like to go in the Great Pyramid, which was closed at the time. And it had been closed for a while because of cleaning. They were cleaning on the inside, which had kind of surfaced a lot of conspiracy theories about Zahi Hawass digging a tunnel to explore behind Gantenbrink's door before they drilled it. So anyway, so he gave us permission. We got inside the Great Pyramid, and I was very fortunate to capture some photographs of the Grand Gallery ceiling, where I noticed that there were scorch marks, and yeah, the place had definitely been cleaned. Even the ceiling of the Grand Gallery, which is 28 feet high, had been cleaned.
And you've noticed scorch marks?
Scorch marks on the ceiling, yes. Yeah. And basically a pattern that is similar, kind of matched the resonator frames that I had theorized were installed in slots in the Grand Gallery in the Giza Power Plant.
Before we go into this resonator, when you talk, did you ever have a conversation with Zahi Hawass about the Giza Power Plant idea or about anything like this, or no?
No.
No, okay.
No.
Okay. Just curious.
I'm not that stupid. I mean, I may be a little zany, but I'm not stupid.
Yeah.
I kind of had his measure, and I just figured, yeah. He asked me what I was doing now. There was a meeting before the filming, and we met in the Sheraton Hotel in Cairo. And,
do you know if he's aware of your book? Do you know if he's aware of your book?
I believe he is now, because it's becoming a hot property in Egypt. See, the thing is, and this is why I wrote my second book, Lost Technologies of Ancient Egypt, because, in the Western world, there was obviously a huge wall of resistance to changing the history books on Egypt. But I wrote the Lost Technologies to appeal to Egyptian engineers to do their own study. And guess what?
It's tiny into the wedge.
They did. And so now, well, just this last week, I got a message from two people. The first one was a video, YouTube video on Arabic television of them discussing my next book, The Tesla Connection. These are the Tesla Connection. Yeah. So they were discussing that.
Who were the people discussing it? Were these like young
No,
people?
it was a reporter. It was on national television.
Oh, wow.
Yeah. And then just today, I see in my Facebook messages a message from Amada Anwar, who is the principal in the Scan Pyramid mission team.
Yeah.
Has
The
sent
Scan Pyramid
me
mission.
a YouTube video of somebody discussing the pyramid as a power plant. And so everybody in Egypt, I mean, not everybody, obviously not everybody, but the youth, the young people, in Egypt are turning their back on the old Egyptology model when it comes to the pyramids. And even some Egyptian Egyptologists are now saying, no, the pyramid as a tomb is a dead theory.
Wow.
Yeah, not just one of them, a lot of them.
Really?
Yeah. Well, think about it. I mean, think about it. Here you are. You've got some of the most amazing monuments and artifacts that this planet has ever produced within your country, right?
Right.
And you compare those with those produced in other countries, like in Greece, Rome, Europe, anywhere. I think India it would be a good contender for excellence in manufacturing with their temples. But if you're in Egypt, you're Egyptian, and you're looking at this and you say, this guy is saying that the ancient Egyptians were more advanced than the Greeks, the Romans, or any other culture on the planet. And they will rewrite their own history, not me.
Ben was telling me that some people have even attacked Graham on this idea. They've gone as far as calling the idea that the Egyptians didn't build the pyramids as a racist idea.
Well, who's saying that? Graham's not saying that.
No, people are attacking Graham, saying that idea is a racist idea. That's what Ben told me, because they said that if you say that the Egyptians didn't build them, you're saying that they weren't smart enough or intelligent enough to actually build these things.
Well, that is a...
which is the implication, but they're throwing bullshit into it, just trying to label him and slander him and basically discredit the idea by injecting drama, right?
Yeah, and
But the people that don't read into it, people that just read the headlines, the lazy people that will see that and just like Graham Hancock, oh yeah, racist ideas.
Yeah, the people who attack Hancock like that, and me, by the way, because there are a few out there that are attacking me, they're just building their own funeral pyre because they're going to get burned to the ground eventually. It won't be by me, it won't be by Graham.
Right.
Yeah, but the Egyptians are coming along. They're very, very fine, intelligent engineers. And speaking of supporters in Egypt, I'll show you an image here. Galal Hassan, Dr. Galal Hassan. That's me. I'm presenting my book to him. He is a professor emeritus in mechanical engineering at Cairo University.
Oh, wow.
Right. And so in his last paper, which was number 109, I believe, he dedicated it to me.
Mr. Dunn is a science lover of the ancient Egyptian civilizations who is keen to visit Egypt and spend some time between its monuments and heritage. I have the honor to dedicate this research work to him and hope my efforts will complete his work to clarify the sophistication of the mechanical engineering technologies used by the ancient Egyptians.
And he actually got his PhD in Bradford University in England.
All right, so going back to this Grand Gallery, you said that Zahi Hawass let you into the pyramid after it had been cleaned, granted you some special access, and you noticed at the ceiling of the Grand Gallery, which is how many feet tall?
28.
That there were scorch marks.
Yeah, so that's the photograph of that. Right here, you see those scorch.
Okay, what is this diagram here down on the left?
Okay,
These
so
balls going up.
this is what I wrote in the Giza power plant. Was that there are 27 pairs of slots on the ramps, the side ramps of the Grand Gallery. Okay, so if you look at this area right here, you see the ramps, right?
So that's looking into the Grand
That's
Gallery.
looking along the length of it. Right.
Okay.
And so I speculated that the Grand Gallery had held these resonators, and I had designed these resonators. I speculated maybe they were Helmholtz resonators, but any a resonator that will convert vibration into sound, airborne sound.
Okay.
Now that may not be a Helmholtz, probably wasn't, but it was some device that was caused to move, and as it moved, it produced a sound. That sound was at a particular frequency, and the design of the gallery was such that that sound was naturally focused to that passageway that leads to the King's Chamber. I have the frames, right, and here you see that they line up with the scorch mark. So in the Giza power plant, I proposed that there was a hydrogen explosion in the King's Chamber, and the evidence that exists that prompted me to speculate that was the Petrie, when he was doing his measurements, noted that the King's Chamber was expanded. It had expanded from its original dimensions about half an inch.
And how did that explosion happen, do you think?
Hydrogen explosion. I would speculate that there was a time in history when you had this remarkable civilization that were in possession of advanced science, advanced engineering, advanced mechanical and machining, and all of those facilities that we use daily to keep our civilization going existed at some level. Maybe not as sophisticated as ours, maybe more sophisticated as ours. But then there was a cataclysm of some kind. We're talking about different periods of time in history, whether it's 9,000 years ago, 10,000, 12,000,
Yeah, based on ice cores that have been taken out of Antarctica, they determined that the world was heated up in like an instant to like incredible heat and then flash frozen instantly after that. And there's been evidence, and people like Randall have done research on this, that they've found evidence of meteors or comets hitting the Earth over a period of 1,000 years. It's called the Younger Dryas.
So that is and then I think Robert Schoch's view is the coronal mass ejection. So all of those things may have been at some point in time. The comet strike is probably, I think, the most convincing in terms of the effect that it had on the pyramids, because the pyramids were built, were finely tuned to resonate to the frequencies of the Earth. And so they were drawing energy out of the Earth there was a known quantity. So their relationship was like, okay, we're building it to withstand a certain amount of power to come through it. And then a comet strikes, okay? Right. And so as long as we were a contained system, working with known energy levels, everything functioned okay. But when you introduce energy from an outside source of such a massive amount, then the coupled oscillator would become what is known as a runaway vibrator. In other words, it cannot pass through the amount of energy that it is receiving. It just can't handle it.
Which causes a hydrogen explosion.
Which causes, first of all, that probably shut apart. You have a closed system. The blocks were stripped off the outside. Whatever mechanisms that were attached to the shafts on the outside, the King's Chamber shaft, were removed. It was exposed. Air, oxygen entered into the King's Chamber mixed with the hydrogen, and then the spark just set it off. Maybe coming from the outside, right. and down into the
right. So everything inside, all the intricate parts inside these chambers and these shafts, like the shaft here, would have been fried, causing scorch marks on the ceiling. Now, when you came up with this diagram of these frames with these round things in the middle, what are those round things supposed to be?
Well, resonators. I identify them as resonators of different frequencies. So they resonate at different frequencies.
And did you come up with this diagram before you saw the scorch marks? Like, did you theorize that that's what it would look like inside the Grand Gallery before you saw the scorch marks?
Well, it was in my book in 1998, and I didn't know about the scorch marks then. And the scorch marks weren't visible until 2001.
When they cleaned it.
After they had cleaned it.
Wow.
Yeah, I mean, there's more too. I don't know if we're going to have time to get
Let's go deeper, Mr. Dunn.
I'm going to have to talk to my union rep.
What's up, guys? That's the end of part 1 of the 6-hour marathon with Chris Dunn. Part 2 is going to be dropping next Monday. We're going to be going deep into how Chris actually reverse engineered the Great Pyramid to show how it produced energy, his theory on the function of the boxes inside the Serapeum, as well as the work that aerospace scientists at Rolls-Royce are doing to reverse engineer the precision artifacts found in ancient Egypt. You're not going to want to miss it. Do me a favor. We just finished covering the last 3 hours. We sort of covered your background in machining and engineering, and we got into all of the details of the Great Pyramid and the different chambers and shafts, which you theorized essentially that the Great Pyramid of Giza is a solid-state electron harvester that gathers electrons from igneous rock deep inside the Earth and creates microwave energy. Did I get that right?
Yeah.
For the most part.
For the most part.
Okay.
Right.
All right, so we're jumping back in. And we also talked about how there was a discovery, there was a huge hydrogen explosion inside of the King's Chamber.
That's what I theorized, yeah.
And the theory is going back 12,000 years ago, roughly, when we know that we don't know exactly, but it's potential that could have happened during the great cataclysm that has supposedly happened 12,800, 13,000 years ago when a series of comets hit the Earth. Potentially comets could have been solar mass ejections.
I have to be clear on one thing, though.
Yes.
No, two things.
Okay.
One is that as far as when the Great Pyramid was built, and as far as who built it, I have no opinion on it.
No opinion.
I just focus on how and why.
Right.
Just focusing on the engineering. Now, as far as the who and when, my position is that it's up to the Egyptians to decide answers to those questions.
Why is it up to the Egyptians?
Because it's in their country.
Oh, you're talking about the specific people that are involved in the science behind the stuff that are in Egypt, not necessarily. You're not referring.
Well, I mean, I think you're talking about different disciplines. Okay, so to understand the function of the Great Pyramid and to get it to work again, then you are going to need your physicists and your scientists with technical skills, on many levels. But as far as deciding the history of it and the time period when it was functioning, that could involve another branch of academia or the sciences to understand those questions.
Right.
And so, I stay out of the historical thing. And also the whole issue of one thing I've always avoided is, resorting to Atlanteans or aliens. And there's good reason for that. When you look at history and the Egyptians and what they have experienced, from outsiders who have come to their country, whether it's from Napoleon, to the British and the Germans and the Americans, they see a lot of their treasured artifacts left the country, and some of those artifacts they're demanding be returned or requesting they be returned. And so another aspect of that is not just the physical artifacts are now leaving the country, but also the heritage is being questioned, and by some people who claim that the Egyptians were not capable of doing that. And so, therefore, it must have been another race. And I think that is where there is a misunderstanding in terms of how that is interpreted by the Egyptians, because it's like, it's not only are they ripping off our artifacts, but they're ripping off our history and our heritage. And so they're very sensitive to that. And I don't want to do that because we don't know. And, when you consider looking at these artifacts that are beautifully crafted, beautifully finished, And if you look at what happens to any civilization after a cataclysm, what would happen to its industries, to its scientists, to all the specialized skills that exist within the culture that make that civilization function. I mean, it's so myriad and dynamic and varied and nuanced, and it's, no one person can interpret everything about what happened in a particular culture at a particular time. There's nobody. Archaeologists, historians, they don't know. They just have a very, very narrow field of view into society today.
Right.
Can you imagine what they, the viewpoint in societies that lived thousands of years ago? It gets really murky really quickly.
Yeah.
So if you think about it, if our society, if America was suddenly hit with a comet and everything was destroyed, we would be brought to our knees. All our technologies would disappear over time. Everything would be destroyed. A large section of the population would disappear. There would be an extinction event. There have been in the past, and there could be again. So what happens then? I mean, in terms of the survivors, what are they going to be doing? They're not going to be going on Facebook and checking their iPhone. Not for long. All the cell towers would go down. Everything would be gone. Right. So they'd be stuck in caves trying to survive, scrimping. So how long does it take a person who is reduced to rubble, everything that they've known and enjoyed, how long does it take for them to build back to that particular stage, right? And to say that the people that survived a cataclysm in America were not capable at some point in their history of doing wonderful and amazing things, and having brilliant scientists arise out of the general population and do brilliant and amazing things, to say that that particular culture could not support an advanced civilization, I think is wrong. It's just a matter of our civilization has been dependent on, first of all, resources, right? Human resources, and also the physical resources of nature that provide us with abundance and freedom for educating people and developing programs where instead of being out in the field digging potatoes or whatever to feed the family, they're sent off to university to learn physics, and it's kind of like that development. You have to have that the underpinning of science is based on people having that kind of freedom. And people around them that recognize that they are different and that they should be nurtured and developed, and they can eventually benefit everybody. And whereas if you're just living in an agrarian society and just to live, just to survive, you've got to work the land. The education institutions no longer exist, and if they did, you won't have time to go to them.
Right.
Or they may be repurposed to do something else. I don't know. So it's a scary thought, really, when you think about it.
Yeah, if it wasn't a crazy advanced civilization that had essentially hit the reset button on everything.
Yeah.
We would, like, if that happened right now, we would have, within 500 years, there would be no evidence of any of the skyscrapers. There would be nothing left except for Mount Rushmore, the Great Pyramids, and like the Hoover Dam, right? The stone structure would survive.
Maybe, yeah. So, I mean, it's kind of like to say the Egyptians, because when you look at how they lived and worked 5,000 years ago, I mean, they did have an amazing civilization just at that period of time. But to say that there was no point in their history when they were capable of building the pyramids, I think is a mistake. You just have to know what period of time it was when the destruction came and everything stopped.
Which is a very interesting perspective that I haven't heard anybody. It seems like there's so much war going on between people that are talking about this and debating this. It's become such an entrenched ideology and almost like a religion for some people, to where they just want to fight. But like you said, yeah, it is entirely possible that the Egyptians that came later were just the survivors of who came before, who had the tools and had the machines to build some of these insanely precise structures and objects and machines.
Right. I mean, the evidence is there. All you have to do is recognize it, take measurements.
Right. Yeah, like you have done. So we're looking at the Queen's Chamber right now on our slides.
So we talked about the hydrogen explosion, and it would be probably a good thing to talk about where the hydrogen was created.
Yes.
And why hydrogen is considered to be the gaseous medium where laser activity takes place.
Okay.
So if we look at the Queen's Chamber, it had two shafts in 1872. Wayman Dixon detected a crack in the wall and found that you could push a rod through into conceivably an open space. So he had the limestone chiseled out. Initially, they were not connected to the chamber.
Really?
Right. See, that's a very, very important point, is that there was a 5-inch, what they call a 5-inch left, it's been called, where the shaft was cut almost to the inside wall, but 5 inches remained. Then there was a crack. So 35 inches, there's a crack. Right. Then in 1993, Rudolf Janssen explored this shaft, and he found that it ended at a stone block. Okay, before I go further with this, I should add that Wayman Dixon also opened up the northern shaft by tapping on the wall and detecting a hollow space directly opposite the other shaft. He chiseled the limestone out there and opened up that shaft. So you got two shafts that are closed off at the chamber. They don't connect with the chamber. They just have that layer of limestone.
Why do you think they weren't connected to the chamber?
There's a reason for that. I'm getting to it. Good question.
Thanks.
So anyway, when Janssen brings Senny's robot up, he found the what has been known as Janssen Briggs door, right? Everybody's heard of that. And then through the door, he saw that there were two fittings, metal fitting. I haven't read any metallurgical analysis of what the composition of the material is here, but they have some very unusual features. Number one, which is important, is that the one on the left here, that's here, is shorter than this one.
Yeah.
They found a piece of it that was on the shaft floor, further down from it. So it had broken up or dropped off and fell down. Right. This one was intact, And but you can see that it was tapered from the top to bottom.
Right.
You see a little tapering on that.
Right.
Okay, so there's a reason for that. So essentially, once that was discovered, and they were talking about drilling a hole through that limestone block, it's called a door. I mean, that shaft is only like 8 inches square. So a door for what?
No
You know,
door
it's just a
there.
misnomer.
Okay.
I think actually, you know, Hawass was involved in that. And a door, it seems like, okay, we'll call it a door because maybe Khufu's tomb's behind it.
There's some treasure back there.
Oh yeah, so it's a door to some other mysteries.
Right.
Right. So anyway, when they were testing the thickness on the door, I had published it in my book, this image right here, and basically I'd speculated that behind these copper fittings or whatever material they made,
Right.
were connected to some cables that went down to a chamber, and the reason for the copper fittings or whatever materials was to create a circuit. They served as like a fluid switch. So if you can imagine, like, what is the purpose of these shafts where they're closed at the bottom end and closed at the top end?
Right.
Why? What would they be using?
Right.
What would pass through there? There's only one substance that would pass through, and that is a fluid.
How would a fluid get into a closed-off shaft with no openings?
Well, that's it. They had to have been pumped from below, from somewhere below, right?
Okay.
And so the two chemicals, there was a chemical engineer that worked at the company I was working at, and his name was Joe Krajewski. And I said, well, okay, what two chemicals could I mix to produce hydrogen? And he gave me a formula for it. It was hydrated zinc and a dilute hydrochloric acid solution. Okay. So looking at the erosion or corrosion of the of the pins, and considering the operation, you have a layer of fluid that is covering the pins, creating a circuit. Okay. And so electricity flows from one of those, I call them electrodes, one of those electrodes to the other electricity as well.
Okay.
Okay. And so that signals a closed condition.
Okay.
All right.
Okay.
So when the fluid drops below the level of those pins, then the circuit opens. Now, what is important is the metering of this fluid into the chamber. And so, you know, by gathering information from numerous sources, right? I was puzzling over the Queen's Chamber shaft, and I was talking to a civil engineer. He was doing percolation tests in the property I had in southern Indiana. Well, southern Indiana has a lot of limestone, as you know, right? And so I was out talking to him as he was doing a percolation test. And basically what that is, he digs a hole, right? And then he fills it with water, and then he times the disappearance of the water to determine how many cubic feet that you would need to handle a septic system, right?
Okay.
For a house.
Okay.
And so basically, you know, your fluid waste goes into a septic tank, and then it's dispersed through these drums that will distribute it through several pipes and into the surrounding soil. So I asked him, I said, well, what do you do if you're doing a percolation test around Bedford where there's a lot of limestone? What happens then? So you dig it into limestone, do you still drill a test hole and fill it with water? And he said, yes. I said, really? He said, yeah. He said, you drill your test hole, and then you determine what the dispersion rate is of percolation. And I said, well, okay, that's interesting. And what determines the percolation rate? He said, the head pressure.
The what pressure?
The head pressure.
The head pressure.
Right. So really, that is the weight of water, or the weight of the fluid that's pressing down on the limestone, pushing it through the limestone. You got it?
Yes. So it goes through the limestone.
Goes
at a
through the
certain rate.
limestone at a certain rate. But in order for that rate to be precise and continuous, the head pressure, or the column of fluid, has to be maintained at a certain level.
So how exactly does the fluid get in there? It gets in through these two things?
Well, no. I propose that there was behind this particular limestone block, there would be a vertical shaft going down to the bedrock, and where you have the equipment necessary and supplies necessary to pump more fluid behind the Ganton Bridge door, and then replenish the shaft and maintain that level.
And it replenishes the shaft by going through the limestone, which is the door?
No, there's a gap underneath the door, and there's also a notch on the side. So, yeah, there won't be any problem with it going through there.
So
another point I want to make is that, you know, a part of the evidence to support that idea.
There's a gap under there?
Yeah, there's a little notch in the corner over there.
Okay.
Is those pins are tapered top to bottom. They're thicker at the top to the bottom.
Right.
Right. So if you've got a corrosive fluid that is covering those and then slowly dropping, then you would actually have a corrosive effect that would leave a taper, because the lower parts of that pin would be submerged longer than the upper parts of the pin.
Right. And then when the fluid gets to below the pins, not touching it anymore, that's when they're triggered to fill with more.
Right. Exactly.
Okay.
Exactly. And notice this kind of substance around there. It's like an insulation, right? Well, this becomes a little more interesting as we get into further research.
Okay.
All right. Okay. So we got that. Now, when they actually did the exploration, they used this is like an impact tester, thickness tester, where
of the door.
Of the door, yeah.
Yeah.
So they measure the thickness of the limestone. They're recording it down there. It's 3.25 inches.
Okay.
Right. And so in my drawing, I had illustrated 3.64 inches. So it's just a little bit off, but still close, right? So this is before they drilled. After they had drilled, they found that there was no indication of wiring in their images because it was like a fisheye lens and everything was focused,
Yeah, straight through.
straight through, and there was no articulation of the camera or anything like that. So they were unable to look around. But I had kind of modified my theory a little bit and posted it on my website, and I proposed that the shaft may exist, but it may have been on an angle and it may go to the outside, to the south. So, it's just like, okay, we get more information, we adjust the theory, and we could still be wrong, right? And I published all that, but at least we're making progress, right? Okay, so then, after that, the Jedi program, there was a dentist from Hong Kong who was very, very, very energetic and very persistent, visiting Dr. Hawass numerous times and trying to get permission to do an exploration. And he got a team together from England, Leeds University, and so they created a robot. They called it the Jedi.
And they were going to put the robot where?
They're going to put the robot up the subship.
Okay.
Maybe. Actually, I should probably go in order. Before that, okay. When the pyramid, it was a pyramid rover in 2002, when they explored the southern shaft and they drilled through it, and they went up the northern shaft.
Oh.
Gantenbrink tried to go up the northern shaft when he sent his robot up there, and it ripped the ceiling and the floor, and he couldn't get around some obstructions in the bend.
Okay. The bend that goes around the Grand Gallery.
Right.
Okay.
And so the pyramid rover team, what they did is they turned their device on the 90 degrees and gripped the walls instead of the ceiling and the floor.
Okay.
And they visited found the same kind of condition, a blockage at the end of the shaft.
Wow.
And the pins in this case look a little different than they did in the southern shaft. So the pins here are basically, you have the left one has this kind of a white substance on it, and on this particular pin, it's clear. This pin also is recessed in the granite. I mean, in the limestone. The limestone was cut away. There was a groove cut away, and that pin is recessed in the limestone. I got an email from a guy in England, and he said, they used the recessed cathodes to extend the life of an electrode. And I was like, cool, that's pretty good.
So these recesses weren't evident in the south shaft, though, just in the north shaft.
Right, just in the north shaft.
Okay.
Well, there's something else. There was something else in the north shaft that was recorded at that time, but it remained hidden until just like a couple of years ago, 2021, which we'll get into.
Okay.
We'll go back to the Jedi exploration, and what they explored the southern shaft with their robot. They got to they had an articulating camera that went through the same hole that the pyramid rover drilled, and got to look around. And interestingly, you see that the pins, when they push through and enter the space behind Gantenbrink's door, they're looped around and seem to be locked into position in the back of the so-called door. And so you also see in this is a kind of like a white substance around that, right? And then on this one, it seems fairly clean, except this is seems like this is some kind of a little washer or something.
Put a stain on the corner from stone.
Could be. You never know. I mean, until you physically examine everything, you can just speculate, I guess. They also were able to look on the floor behind the door, and they picked up these symbols that were painted with presumably red ochre on the floor. And you have this.
What is that?
Device right here, and then there was kind of like a letter 5.
That does look like a number 5, doesn't it?
Yeah, and something similar here, but it's hard to really tell.
Yeah.
So, and then there was also a line, right? Which was basically right in line with the pins that came through the door.
Okay.
Right. So they didn't know what those markings were. They assumed that they were Mason's marks. I actually said, well, no, they're electricians' symbols, electrical symbols, and what this one is a twisted pair, right? So you got a cable with 2 wires coming out of it, and then a couple of clips, one on that side and one on that side, positive and negative. And then the line on the the line on the floor is to identify the polarity of the door. So it's really a wiring diagram.
Sorry to interrupt, but this episode of the podcast is brought to you by Verso. We all know how important it is to get the right amount of nutrition, exercise, and sleep as we age. It's something I'm really passionate about and have discussed at length with doctors and nutritional scientists on this podcast. That is why I use Verso. Verso is a company dedicated into translating scientific breakthroughs into products that hold the potential to increase longevity. I take Cell Being every day to help combat aging by increasing my NAD levels with powerful ingredients such as NMN, transresveratrol, and TMG. NAD+ is arguably one of the most powerful molecules in the body, but declines with age. Keeping NAD+ levels high helps guide longevity genes called sirtuins. Sirtuins are called longevity genes because by activating them, they support overall health and slow down aging-related effects by regulating important processes inside of cells. High NAD+ levels can improve your metabolism, repair damaged DNA, and ramp up energy production in your brain, immune system, and muscles. Now, you can't take NAD+ as a supplement because it's too big for the cells to absorb. But NMN directly converts to NAD+, while resveratrol activates your sirtuins, which increases their attraction for NAD. These two molecules act synergistically and increase your NAD+ more than just NMN on its own. Verso also publishes third-party testing from each batch produced to absolutely guarantee you're getting what you pay for. Head on over to ver.so and use the coupon code DANNY, it's spelled DANNY, to save 15% off your entire order, or just go to ver.so/Danny. Back to the show. How would people get up in there, though, to read that?
Good question. When you read more of my book, you'll find out.
I read the whole thing. Maybe I blacked out on this chapter.
No, the whole
Or
thing.
maybe I know the answer, I'm just asking you.
It is a maintenance issue, right?
Right.
Because if you've got, it's like, okay, so we see that one of those electrodes was heavily eroded to the point where a part of it broke off, right? Without presumably any intervention by human beings or man or mouse, right?
Right.
There had to have been some action on that particular electrode for it to break off. And that's where your dilute hydrochloric acid comes from.
Okay.
Okay. Then, the other part to that is because that broke off, and because it is an item that would need to be replaced on occasion, then they would have to have some way of accessing it.
Mm-hmm.
And I first thought about, that there is a theory put out by Jean-Pierre Houdin, who claims that there was an internal ramp, and they used that ramp to haul stones up and build the pyramid. And so I was thinking about the internal ramp, but then I kind of settled on the idea that the most efficient and quickest way to get to that particular spot would be on the south face, just a very short tunnel. For maintenance workers to reach the back of that door, pull out the existing door, and put another one in.
So they could remove the outermost blocks of the base of the pyramid and just go right in there.
Yeah, so there would be some way of accessing it on the south. There would have to be some way of accessing it because, obviously it would need to be replaced periodically.
Okay.
There's a drawing in my book that where I show that.
Right. Okay.
So that's it on the southern shaft, and so there is still more to learn about at what point or where the fluid is introduced. I had assumed that the fluid was introduced behind the blockage or behind the Ganton Briggs door and its counterpart on the north side. So my scheme was that the chemicals would be delivered to the back of those blocks. Right. That was until 2021, and there's a YouTube channel, Ancient Architects, and they created a video that showed all the a load of photographs that were taken by the pyramid rover that had never been released to the public before. And it was the pyramid rover actually photographed at stages as it was climbing up that shaft to reach the so-called door, the blockage, right? And about halfway up, about 90 feet up, they came across this. So there's an opening in that shaft, and it's near one of the bends. You see the two rods there; those were exploratory rods that were pushed up there. And you can also see that there's a lot of trash in there.
Yeah.
But the area in front of that opening is fairly clean.
Yes. How far up the shaft is this door? This opening?
98 feet.
98 feet.
Yeah.
Wow. And is this in both north and the south shafts?
That is a good question. So we still have to...
This is south or north? Right here.
This is north.
North. Okay.
This is north. And it's on the east side, right?
I'm sorry, I'm blanking, but north is the side of the
Entrance,
door?
with the entrance.
Not Ganton Briggs door, that's
That's the south
Okay,
shaft.
got it.
Yeah, this is the north shaft. Ganton Briggs is on the south.
Okay,
south.
this is the one on the side of the Grand Gallery.
Right, exactly.
Okay.
Right. Oh, that's a whole south.
So where does this space lead to? This little access?
That's an unknown right now.
How could they not have found out where this goes with all the scans that have been done?
Well, it was actually in an article that was written by Zahi Hawass, and this image appeared in that article, but it was in some arcane journal, or, it's, and no mention of it whatsoever. It seemed like everybody was more interested in the destination rather than the journey. They were just pressing on to seeking the end of the shaft rather than paying attention to what was appearing in the cameras on the way up there.
That's insane.
Yeah, isn't it though?
So this could be where they introduced the chemicals.
Right, exactly.
Where do you speculate the other end of this little doorway is?
Right here.
Where's this? This looks like it's outside.
It's outside the pyramid, and it's on the east side, near the center of the pyramid.
Okay.
Okay. So this vertical shaft is like there are two parts to it, right and left. Right? But it's kind of interesting. The surface of this wall, or what we're seeing right here, the back wall, is kind of interesting. It doesn't appear to be natural limestone, and it's kind of like there's a separation between it and this wall right here. You see?
Right.
Right. So I don't know, what has happened in prehistory.
It looks like stairs down there.
Yeah. But no, they're not stairs.
Oh, okay.
But the funny story, when I was there in 2021, my hat blew off and landed down in there.
Oh no.
Yeah.
Did you go get it?
No, a very nice young man, Egyptian young man, jumped down and got it.
Oh, that was nice.
Yeah. So it was windy. But what I would like to do is to, do an experiment and fill the north shaft, just cap it off in the Queen's Chamber and just pump water in it until it reaches the level of that shaft, that opening, and then monitor what goes on the outside and see where it goes. I suspect.
How do we get the liquid into the north shaft? Through here?
No, through the Queen's Chamber. Go into the Queen's Chamber, cap off the northern shaft.
And fill the Queen's Chamber with water?
No, fill the shaft with water. Just start pumping water into the shaft.
Okay, pump water into the shaft and then see if water comes out of here.
Right.
Okay.
That'd be cool if we could do that. Probably not in my life.
Or couldn't you just fill this thing up with water until it eventually comes out of, see if it ever comes out?
No, you could never do that. So you never could do that because of the different levels.
Oh, got it. Okay, yeah, that makes sense. It would just start pouring out of here. I got it. Yeah, gravity.
Gravity.
Damn gravity.
Damn gravity. So
wow. So this would be potentially, what do you think the function of this would be? This opening here outside of the pyramid?
This would facilitate some means to deliver the chemicals to the individual shafts, one on the northern shaft and the southern shaft.
But didn't you just say if we poured stuff in there, it would never reach the shaft?
Not without pushing it up there.
Oh, you have to push it.
You'd have to push it. So, you would restore it to its original
That
function
is cool.
and pump it up when there's a signal for more chemicals.
Okay, so it would have to be pumped through there. Got it.
Right.
And, okay.
So then, basically what we're doing is we're taking the idea that chemicals were pumped all the way up here, and then, I think it makes, those Egyptians, they were brilliant. Weren't they?
So this east, on the bottom here, this east side bedrock chemical supply shaft, it looks like it's under, because this is a 2D diagram. This is actually on the outside, coming towards us, right?
Exactly.
And those shafts, there's two outermost shafts that connect to it.
That's the speculation
On
at
the
this point.
south, right,
You know, what the reality turns out to be is another matter.
Right, right.
Right now, there's hints. There is an area in the southern shaft that is of interest. Hopefully, that they will be able to find something out soon if they go back in there and explore it.
Okay, so this is assuming that same little opening is in the southern shaft, but we only have found it in the northern shaft.
Right. Right.
So chemicals are being introduced through this outside shaft, through the ground, being pumped up into these south and north shafts, which slowly introduce these chemicals into the Queen's chamber. And inside of the Queen's chamber, what is happening with that chemical reaction?
Well, ultimately, they would be mixed and boil off hydrogen, and the hydrogen would fill the interior of the Great Pyramid. Now, there's other evidence that we haven't discussed. And early explorers in the Queen's Chamber found that the walls were encrusted with salt up to about an inch thick.
Really?
Yeah, it's funny how that happened.
When was this?
I don't know what to do.
Long time ago?
I mean, if you're reading Piazzi Smythe, then you know he was reporting on earlier visitors being driven out of the chamber by a noisome odor, which kind of suggests a chemical reaction, kind of like opening a can of
Odor, yes.
smelling salt. Right?
Yeah. Oh, what happened to those smelling salts? Here they are. In case we need them.
Yeah.
The world needs to see Chris Dunn huff some smelling salts.
No, they don't.
So this is an experiment you reproduced in a lab. You reproduced what would be happening in those shafts with those electrodes were going through the door.
No, you're fine.
Nice.
Basically, I created a model out of plexiglass of the Gantenbrink, so-called door, and I crafted these electrodes with the loop on the end, and also fitted it with clips shaped like a number 5, and wired it up to a light source, and then I made a model of a tank, right, same dimensions as the southern shaft, but
Okay.
a much shorter length, obviously.
8.4 by 4.8.
No, this is more like 8 inches square.
Okay.
Right. So then I, fitted it up and demonstrated it to work. So that's it was a setup in the lab at Danville Metal Stamping, and the basically, that I actually took that photograph after the liquid had dropped, but I demonstrated it for the Ancient Aliens folks, and I had everything set up with the lights off, and then filled the tank and brought the liquid up until it covered the pins, and then the lights turned on, and so everything worked.
That's wild. So as soon as that liquid, which is what exactly is that liquid again?
That's just regular water
Okay.
with some food coloring in it.
Okay. And as soon as it reached the pins, it turned on the light.
Right. So then the other part of the experiment was to create the hydrogen, and I mixed the zinc and hydrochloric acid, dilute hydrochloric acid, and so the hydrogen boiled off, escaped through that chimney, and I put a flame to it.
And is that like a solid flame that's being created right there from those the zinc?
Just where the gas is coming out of the top of that chimney.
And it's sustained like that? It stays like that?
Yeah.
Wow.
Until the reaction in the chamber stops.
Right.
In the vessel stops.
Right. So that would be the effect inside the Queen's chamber.
Yeah. Except without the flame, we hope.
Has there been no evidence of any other artifacts that could have been like the guts of the pyramid?
Good question. One point before I address that question.
Okay.
And if I forget it, remind me, because I'm getting old now. Right. Another point to make is that when I made those pins, and I inserted them into the hole and then bent them down 90 degrees, right? Mm-hmm. I had to apply a little heat, and the pressure that I had to exert on the end of that to cause it to form was a fairly significant amount of pressure that I had to put on it. And so when you look at the pins that are there now, and the fact that one of them on the left broke up, there's no way that those pins, the one on the right or the left, could have been bent into that position after being installed.
Right.
Right? They would have broken off before you actually got there. Because when they went to test the thickness of the limestone, whether intentionally or accidentally, the one on the right was shortened and broke off, but nobody said anything about it.
Well, couldn't 10,000 years of corrosion just make them break?
You can believe that if you wish. But then how do you explain the northern shaft not being broken?
I mean, yeah, I guess it's just chance. If you got four metal pins and ask them all to survive 15,000 years, I mean, there's a chance one of them would break and 3 of them wouldn't, right?
I doubt it.
Okay. Fair enough.
It's left alone with no interference of anything, any mechanical,
Right.
chemical kind of, no. Okay, so there's one thing that I wanted to touch on that we kind of moved past rather quickly. When we were talking about the input signal from the northern shaft and then the south shaft with the horn antenna. The inlet point on the north shaft, the shaft goes through a series of bends, right? So you see 1 bend, 1, 2, 3, 4 bends before it enters the King's Chamber. Mm-hmm. The point where it enters the King's Chamber is 1/4 of the distance of the length of the chamber. So in, like a resonant cavity, a standing wave, the quarter wave point is considered to be a point where the highest amplitude of sound would exist, or the energy would be the greatest at the quarter wave point. Mm-hmm. That's a significant point. The other thing is that there are 4 bends rather than just 1 or 2. Why? And that is in the design of waveguides, that, according to my good friend and aerospace engineer Eric Wilson, are used to correct the beam. They go through different kind of steps. Mm-hmm. So you'll find along the shaft there is a step down in one area. Another place there is like a bump where the shaft is constricted. And so he believes that those are definitely, like fingerprints of an ancient weight guide. The other point to make is you see where the shaft is located, right? And the theory about why it is bent is to pass so it doesn't interfere with the Grand Gallery. And you'll see where if it just went out straight without those bends, it would miss the Grand Gallery.
Right.
Right? And so that seems to...
By about 3 feet.
Yeah. And then when you look at when it finally takes its last bend and goes up past the Grand Gallery, passes the gallery by about 13.5 feet. So that to me is significant.
Yeah.
It means that, I don't know how thick those wall blocks are of the Grand Gallery, but I can imagine that they are extremely thick.
Meaning that all these bends, they are on purpose.
Yes.
They aren't just to. It's not like they were just figuring this out as they went about building it. It's not like, oh look, this is too close to this. Let's build it out this way. Like no, these bends have a specific function.
Right. This is a
Oh wow.
3D drawing of it. This was actually taken from Gantenbrink's drawing, so he's the one that did all the measurements. And so you see how that looks, right? Compared to if you wanted to just ventilate the chamber, you could just go straight down into it. And, the position where that enters the chamber is so specific. And
The quarter wave location.
the quarter wave location. It's undeniable.
What is so specific about it?
That it's at a high energy point in the resonant chamber.
Oh, okay.
Yeah.
The Cavigal tunnel. What is that? The Caviglia.
Caviglia was an Italian explorer who reportedly dug that tunnel to reach the northern shaft.
Oh, really?
Yeah. And you see where that end eye is?
Yes.
That's where Gantenbrink installed the ventilation fan. Yeah.
And this sort of invisible shaft, the less complicated ventilation shaft, that's how they could have installed it.
No, it's pretty simple.
If they wanted to make it easier.
Sure, yeah. That's the point I wanted to make on that.
Okay, very interesting.
Yeah.
Couldn't we scale this whole pyramid down and sort of test everything on a smaller scale to see if it works? Like to make it a pyramid that's like 1/10 the size of this pyramid, just to see if it works on a smaller scale?
That's a good question, and a lot of people will have asked that. Really, I think in terms of scale, you can't really scale down a weight guide that has specific dimensions in order for it to function.
Okay.
So it's like, it's going to be 8.4 inches. And then as far as how the entire system operates, it covers 13 acres, so it's collecting energy from over a 13-acre area. And if you reduce that down, so you reach the energy levels that you need in order for it to function. So I would say that in some, if you wanted to test the Freund effect theory,
right.
and you wanted to be able to, without all the mechanisms on the inside that you see in the Great Pyramid, you just wanted to force the release of electrons from the lithosphere, and then you would build a simpler system to do that. But the other part of that is also how do you collect that energy, and how do you distribute it? That's the other question. And so this is where I get a little creative.
Oh, look at that. That's beautiful. This episode of the podcast is brought to you by Mudwater. Mudwater is a coffee alternative containing 4 adaptogenic mushrooms. With only a fraction of the caffeine as a cup of coffee, you get energy without the jitters or the crash of coffee. And each ingredient was added for a purpose. Cacao and chai for a hint of caffeine and hot chocolate-like flavor. Lion's mane to support focus. Cordyceps to help support physical performance. And both chaga and reishi to support your immune system. What I really love about Mudwater is that it tastes great, and they took their time to find all the perfect ingredients to develop a product that helps you feel better every single day. Mudwater donates monthly to psychedelic research and treatments, as they believe the country is in a mental health epidemic, and see psychedelics as useful tools for individuals with depression, PTSD, anxiety, and other mental health experiences. So get 15% off and a free frother by using my link below, mudwater.com/Danny, and use the code Danny at checkout to get 15% off. That's mudwtr.com/Danny, and use the promo code Danny at checkout to get 15% off. It's linked below. Now back to the show. So is this what it looked like when it was working?
So
okay, I see the vibrations coming from underneath the earth, hitting up into that 13-acre square bottom base of the pyramid.
Oh, I didn't mean to
And
click
it's,
that.
it's traveling up there, and it's the interesting thing about the first thing I noticed about the chambers in the pyramid, they're not directly underneath the very tip of the pyramid. I would imagine that you want this thing to be symmetrical, like it's off center, which is interesting to me.
That's interesting. The Queen's Chamber is pretty much central.
Okay.
Right? And the top of the Grand Gallery is pretty much central, but the King's Chamber is offset.
It's offset, right?
Yeah.
Oh, wow.
Okay, and I see you have here on the King's Chamber, there's like a square around it.
Well, that's just,
art.
that's nothing. Yeah.
Okay, and this dome, what is this dome that we're seeing around the whole
Well,
pyramid?
that is the Tesla connection.
That's the Tesla.
with the Freund. See, with Freund's experiments, he needed to have the handshaking going on. So as these positive holes are released from the lithosphere, they have to join with negative electrons. Basically, create that energy flow.
So this would be, the energy that's created would be sort of like free energy in the air. It would power everything that they had.
It'd be, based on, it's a nod to Nikola Tesla and his Wardenclyffe Tower, right?
His what?
The Wardenclyffe Tower and his vision of wireless distribution of energy, right? So if you have like a cage over the pyramid, you can have several connection points that go to the surface of the pyramid where that handshaking takes place, and then it's radiated out through the dome.
Whoa!
I know it's crazy, right? Isn't it more like science fiction?
It really is.
Yeah.
But everything is like science fiction nowadays.
Well, the thing is that the more you learn about what the ancient Egyptians were capable of, I don't think you can put limits on your imagination to determine the full extent of it. It's kind of like, we say, well, this can be done today, and I've always avoided that kind of conclusion, that it can't be done today. But I also think at the same time that it's like, well, what else were they doing that we don't know now? We're only just scratching the surface.
We clearly don't think and operate the same way. Because if they were building things like that, they went down an entirely different path than we went down.
Yeah.
Because if we're on the trajectory that we are on now, as far as our civilization goes and the way we harvest energy and the way we do everything, we're going to end up at we keep going down. We'd have to completely start from scratch to get to here.
Well, we may end up that way anyway when you consider, the reserves of coal and oil.
Do you think there's a possibility that we could end up with something like this on our current path?
It would take somebody. It certainly wouldn't be, political. It wouldn't be a political thing. The government probably would do it.
It would be a political thing.
It may come. I don't know. If somebody sees this and decides that money could be made and a profit could be made, then I think that it's possible. Take somebody like an Elon Musk, who is building all these cars. But
He only spent $55 billion on Twitter. He could spend half of that and reconstruct this pyramid, get it working again.
I got a perfect site for him too. You ever heard of Marfa, Texas?
No, where's that?
Texas.
Marfa?
Marfa. Yeah, the Marfa lights. Google it.
Marfa, Texas.
Marfa. M-A-R-F-A.
What's so special about it?
That's a light show all the time. That is earthquake.
Earthquake lights.
Or terrestrial lights, I would say.
Terrestrial lights, right? Which is the same thing as earthquake.
Which is same as earthquake.
Okay.
But there's definitely a lot of activity there.
Wow. Are there big tall mountaintops there or what?
I'm not so sure about that.
Okay.
I just recently learned about that.
Marfa, Texas earthquake lights. We should be able to find something like this on Google.
You should, yeah. So, but then again, this drive for everybody to go electric, and building all these electric cars, how are they going to be eventually powered?
They're still powered by coal and
Right.
these typical power plants that we have now.
In my book, I show a graphic of a coal pyramid next to the Great Pyramid.
Mm-hmm.
Right. In 2021, they mined by weight enough coal to equal 76 Great Pyramids
What?
just in the United States.
That's bizarre.
Very bizarro, yeah. But that's what they did. 76 times the size of the Great Pyramid.
It really baffles my mind that there's not some really smart super billionaires around the world that could be fascinated enough in this technology and just the stuff that you dug into and uncovered and theorized that they would want to sort of back engineer this thing for real.
Well, hopefully people will start to tune into it. I mean, right now my book isn't even available, so people aren't reading it. Right?
Well, the Giza power plant is.
The Giza power plant is, but the Tesla connection is like the Giza power plant on steroids, right? It's got a lot more to it.
Because it introduces the idea of the igneous rock creating energy.
The Freund effect.
The Freund effect, right. And what do the other two pyramids have to do with the big pyramid? Are they similar in construction?
Well, I think that all pyramids really will serve the same purpose. They just performed in different ways. But essentially, you have a very energetic part of the world, which is that part of Egypt, and drawing energy from the Earth's lithosphere. You go to Saqqara, it's a very lively place, very lively.
What do you mean lively?
Vibrations. And,
Tectonically live?
Well, whether it's tectonic or just the way it has been terraformed in a way to, they've got a lot of these deep shafts and tunnels, miles and miles of tunnels in and around, under and around the step pyramid. That whole area is a massive.
It's all part of this.
Energy manufacturing site. Yeah.
Have any explorations been done on the other two pyramids that are next to the Great Pyramids to this level? Like, do they know if they have the shafts and all the chambers just like this?
No, and one of the things that one of the criticisms that I've received over the years is that I seem to be looking at this out of context and in isolation. So I isolate the Great Pyramid and I analyze the Great Pyramid to the exclusion of all the other pyramids. Right. Fair enough. The only thing is that in terms of doing a reverse engineering study, there's more information. The Great Pyramid has produced more information and more interest than any of all the other pyramids combined. For researchers. So, the available information on it and the technical aspects of it and the dimensions of it have been a focus of many researchers over the years. So all that information is like preliminary information whenever you're doing a reverse engineering project. It's taking measurements of what you want to reverse engineer. And all that work has been done over and over.
Right. I wonder if the other two pyramids, though, could have been like backup generators or something. They could have served as some sort of a crutch for the big pyramid or something. If there was any sort of, there had to have been some sort of function for those.
Yeah, I
help.
think they all worked in unison, and they may, played off each other because, frequencies, sound. I've described the Great Pyramid as a huge musical instrument because of its nature.
Right.
When you go on the inside of it.
Right. Now, what about the Sphinx? How do you think the Sphinx ties into it? Do you think that's a part of the engineering?
We talked about Penman's hydraulic pump generator, right?
A little bit, we did,
Right.
yes.
Okay. So if you look at the water erosion, the Sphinx enclosure, and the signs of water erosion in and around the Giza Plateau, there are deep shafts, to near all the pyramids to the east, small pyramids, squeeze pyramids they call them, to the east of the Great Pyramid.
Right.
And then some shafts that have signs of water erosion, some shafts are clear, like no water erosion whatsoever. And then there's a really deep shaft that's off to the south. When I saw it in 2001, they had dug down about 100 feet, and they were still digging sand out of it. So I don't know what the status of that project is anymore. So there was obviously a lot going on, and hydraulics does seem to enter into the picture. And when I look at each of the pyramids individually, and you see different features on the inside, like the Great Pyramid. It has that subchamber. There's no exit point for water to flow to. So when I think of the Cadman model in terms of a hydraulic pulse generator, my thoughts turn towards.
Can we find the Cadman? Is there images of this model?
Probably. Okay. But my thoughts turn to having underneath the entire plateau a much larger pulse generator that causes the entire plateau to vibrate. And so you're releasing electrons, not just for one single pyramid, but every pyramid on that site.
Whoa.
That's the Kunkel.
So what did he theorize that was happening with this?
I don't theorize anything.
No, what was his idea?
I think that is the Edward Kunkel model.
Oh, okay.
Right. Which John abandoned.
Okay.
Because he couldn't get it to work. And he focused on just the lower parts of the subchamber, which he did get to work. But
yeah, he built a replica for this thing at his house, right?
yeah. I went out and visited him.
Yeah, and you mentioned that when he demonstrated it working, you felt some rumblings underneath your feet.
I certainly made the ground shake. Yeah, that was an interesting visit. And I met I was a hydraulic engineer that met us down there. His name was Jack Cole, Dr. Jack Cole. So John started up his machine or his pump, and then he started to flow down into a catch basement. They had I think it was a spring-loaded valve at the bottom, and then there was when the valve closed, there was a shock wave that was shot back up into the chamber, causing the ground to shake underneath. What I found most interesting was the beat. It was beat like a heart.
Like a heartbeat?
Yep. Loved up, about 60 beats a minute. So I found that interesting. But it's like there's a lot of interesting research going on.
Backyard research.
Right. Yeah.
Go up to where it showed right there, the Nile River. Oh wow. So, okay, when Ben was on here, he described the large granite boxes that are in the Serapeum. And I think you measured them personally by hand. You found out they were almost perfectly square inside and polished. And they were in this long hallway and separated almost like it was horse stables. And then they were kind of like depressed down into the floor a little bit too. And people speculate, the Egyptologist theory on this is that those were the tombs, right? That's where they put the mummies.
Supposedly,
that's what they say.
For an Apis bowl, yeah. That's the official.
That's the official name. Right. Okay. Now, what do you think the purpose of those massive granite boxes with perfect precision? What do you think the purpose was for those?
Ooh, do we have time?
We do.
I'd rather just talk about the. I don't know. There is a.
You don't like talking about it?
There's a chapter in my book, right, on the Serapeum, and it introduces some ideas that I picked up along the way, and addresses some of the criticism that I've received. Some of it rather harsh and incorrect, and some of it quite nasty. So, the problem that you have when you're talking about measurements and you're going into obviously a site where work has been performed, whether it is a site you would go to today or a site that was created 5,000, 10,000 years ago, pick your date, I don't know. And you are doing an analysis. How far do you go with your analysis? And what are your motives for going there, right? My history with the Serapeum goes back to 1995. And in 1995, I went to Egypt on the invitation of Graham Hancock and Robert Bauval. Graham was in the finishing stages of his book, The Fingerprints of the Gods. And I had read Robert Bauval's book, The Orion Mystery, and in that book he had described Gantenbrink's exploration of the southern shaft. So I was very interested in that, very excited about it. And so I sent a letter to Robert via his publisher and enclosed a copy of my article, Advanced Machining in Ancient Egypt, which appeared in Analog Science Fiction, Science Fact, 1984, August 1984. It appeared as a fact article, by the way.
Oh, nice. Congratulations.
Not science fiction.
Not pseudoscience, me?
No. And that's another story. Maybe we could talk about that. But anyway, you want to talk about the Serapeum. Then one day, I went over there. They interviewed me in the King's Chamber. And then the following day, they were off to film in the Serapeum. And I met a guy there. His name was Robert McKenty. And he was a Canadian who was doing some research for a website that he had developed. Developed his educational thing. I think it was sunship.com, I think was the name of it. So anyway, he suggested that we get a taxi. He wanted to show me an artifact at Saqqari. And he wanted to get a taxi out. And then after he showed me that, he thought that maybe I would proclaim it to have been a very precise machined artifact. I looked at it and I said, no, it's not conclusive. And so after that, we said, well, Graham and the lads are over at the Serapeum. Why don't we just head on over there? Okay. So we went over to the Serapeum, and they were filming in some part. Robert and I walked down one of the passageways, the underground passageways. And I'm looking around, and this is my first experience seeing the Serapeum, and I'm just like blown away. Never knew it existed before, never heard of it. And so I had with me, I had what we call in the shop, a lot of machinists out there will recognize it. It's a parallel, just a 6-inch parallel that you use in machining vices for machining.
This thing looks like a ruler with a T on the top of it?
No, it's just a parallel, just a straight piece of steel.
Okay.
Very precise edges. I mean, to within about 2/10,000ths of an inch.
Oh wow!
So it's fairly close.
Pretty straight.
Right, pretty straight. And so I jumped down into one of the crypts. They call them crypts. But the interesting thing about these crypts is that they're about 3.5, 4 feet below the surface, the floor of the tunnel, right? So
Okay, right.
And then these boxes that weigh probably 70 tons, the box is about 13 feet long, 7.5 feet wide, about 8 feet high. It's recessed into a recess in the floor. So, the floor was actually dug out, and these boxes were dropped down into the script and then inserted into these recesses. Very interesting. So while there, I just went to I was on the outside of it, and I put the parallel up against the surface of the granite, and I was like, wow, I spent many, many years and hours checking parts, using gauges, working with granite surface plates in manufacturing. Okay, and granite surface plates, they have their own specifications. You have, machinist grade, toolroom grade, inspection grade, laboratory grade. Generally, you're looking at 1/10,000th of an inch precision for an inspection grade surface plate, and generally those tolerances are given as per foot. So you could accumulate a variation over a large surface plate. It's more than that. And so I'm looking at this, and the feel of it is just like I'm back home, right, in the shop and sliding it on a granite surface plate, right? And so I was like, wow, that's unexpected. That was very unexpected. It blew me away. I was like, wow, you don't normally find that, right?
Right.
It's just like, this is a totally out of place artifact. I didn't know the ancient Egyptians were holding tolerances like this, even over a 6-inch
Right.
area, right? Very small area. Right? And so I thought, oh man, well, Robert was an engineer. I yelled, hey, Robert, come over here, you got to see this. And I said, and the producer, who was his name was Roel Lustra. He was with Netherlands TV. And he said, oh, we're filming. Shut up. Go away, boy. Actually, I don't know where they were. They weren't near me, but they heard me, obviously. And so I was like, okay. So anyway, that was interesting. And I left there with a desire to revisit in the future.
Right.
And it was just brief. Like, I may have been like 5 minutes looking at that and taking a quick check, wiping off the granite, and saying, well, that's impressive. Then I went back to Egypt in 1999, and I wanted to go back into the Serapeum, right? And I was talking to a business guy at the hotel where I was staying. I said, I need to get in the Serapeum. Is there any way you can get me in there? And he said, oh, I think I can do that. I have some connections. Meet me here tomorrow night. We'll make arrangements. Okay, so following night I'm there, ready to go. And no, it's impossible. It's dangerous. It's close to the public. Well, what's the problem? Well, there's a lot of water and the danger of falling rock from the sea. Oh, really? Where's the water coming from, I wonder? But I didn't press there. So anyway, that year I was unable to go. I had improved my my data collection tools. So I didn't have a 12-inch, a 6-inch parallel. I had a 12-inch straight edge parallel. It was ground flat to within 1/10,000th of an inch.
Okay.
Right. And I also had a toolmaker's square that was precise to within. It was calibrated to within 50 millimeters. So about half of that, right? Wow. Yeah. So fairly accurate. Fairly accurate gauge.
It'll do.
Yeah. Right. Yeah. Got enough for horseshoes and darts, right? Yeah. So. Then the opportunity came in 2001 to go back in 2001, and that's when I went with Gail Fallon, who was the field director of Grizzly Adams, up to Jay Velasquez's office, and he gave us permission to go. He wrote us a note to give to the director of Saqqara. We went and visited with him. We had coffee, or tea rather, and then we walked down to the Serapeum, and he let us in. It was a very, very short visit because I didn't want to become too much of an interference with his day. Right. So let's put it that way. He was there. He was in attendance, and he was observing. Okay. At the time.
Right.
And so I got into the one box that had the side had been blasted open. It was probably the only one that had a corner that was missing on it, and you could crawl in there. Could you put my feet up there?
Yeah.
Right.
It's amazing that he's just got like the keys to all these amazing ancient places, and he's the one who can let you in. He's the only one with the key. It's so interesting.
Right.
Oh wow.
So.
So okay, is this one solid piece of granite?
Yes. The box itself is crafted out of one solid piece of granite, and the lid probably weighs about 25, 28 tons. It's huge, and so with that square, I pressed it up against the underside of the lid and up against the inside wall.
Were there any gaps?
No, there was like no gaps. I mean, I'm not saying it was as precise as that instrument. It was just a visual observation.
Right.
But anybody who has done any kind of skilled or precision work who looks at that photograph will be astounded by what they're seeing, because what you're looking at are two surfaces that are parallel to each other, and a flat lid that spans the width of the box. Right. So,
what caused the corner to break off like that?
I think they dynamited it or something like that. Yeah. But the things that are missing from the archaeological record it's not just the means to do the cutting and hollowing out of the box, but also the means to inspect it and measure it to within that kind of level of precision. Even though it may not be perfect, and it may not be perfect throughout, I do put a qualifier in my book that the entire surface needs to be scanned and analyzed completely. Now, Ahmed Adli, who is an Egyptian engineer, went into the Serapeum to check me out, and he measured the one box. He was using a digital or a laser distance measure, and then a digital square. I'm not a big fan of digital squares because of the electronics. They tend to drift, and you have to be able to calibrate them. And generally, you would use a square like that to calibrate a digital square.
Do you have any wild ideas to what the purpose of these boxes were?
Oh yeah. It's in my book.
Let's hear it.
It's wild, actually. Wild.
I love wild. The wilder the better, Craig.
Oh, I'm not finished here yet.
Okay, let's keep going.
Okay. So I think overall, my time spent in there was probably 10, 15 minutes, something like that.
What was Zahi saying? You saw you squaring that up like that. Was
Oh, he wasn't with me.
He said he wasn't there with you.
No, he stayed back at the Giza Plateau
Oh, okay.
in his office.
Are you okay, Steven? Oh, okay.
Yeah. So, anyway,
And look at that too. Above your hand on the left photo, the reflection of your hand.
exactly.
That's wild.
Right. So this is an ancient artifact.
How could we recreate this to be? Did you talk to any of these big granite manufacturers and ask them their thoughts on this thing?
Well, I contacted 4 precision granite manufacturers, and these companies make granite surface plates and other precise objects like V-blocks, squares, angle plates, and things of that nature. Also, machine beds for a variety of machine tools, optical beds and stuff like that. You know, granite is very stable as long as you maintain the correct temperature. And so the only company that responded to my request was a company called TrueStone.
TrueStone.
Yeah, and they said that they didn't have the means to create one out of a solid piece.
Meaning they would use 5 separate pieces and bolt them?
Yeah, 5 separate pieces and bolt them together. And he said the material cost would be, in white, and he said white granite would be like $175,000, and they would be, the transportation costs would be extremely expensive.
50 grand?
Right, but the fact that they would not make it out of a solid piece, because if you go to start making these out of solid pieces, then the time for material removal increases, and the difficulties, like even the corners, you're looking at a very, very small radius. It's about 5/32 of an inch radius in the corners. And so there's a lot of consideration when you're looking at a piece like that. But I started to, actually, I think it was 2013 I was there, and I started to explore other parts of the interior, and I noticed that at the bottom, the precision seemed to fall off a little bit.
On the floor of this thing?
Yeah, near the floor of it. So there was it was obvious that, you know, that the box was not 100% throughout precise, but within, I don't know, the tolerance of that gauge or close to it.
Right.
So even if you say, okay, given that the gauge is 50 millionths, let's say that the accuracy of the surface is 1/2000th of an inch, which, you know, if it was, you would definitely see light coming through.
1/2000th of an inch.
1 or 2,000th of
Like
an
a
inch.
human hair?
It's like a human hair, the thickness of a human hair, which is fairly close. It's still extremely precise.
Yes.
And not what you would expect from a primitive culture or
No.
an underdeveloped industry or culture.
There's probably nothing in this room that's that precise.
Oh, no, there isn't.
Not even a like a MacBook Pro or like a TV. Like, do you think that TV is 1/1,000,000th of an inch, or what was it, 1/1000th of an inch square?
I don't know, it could be.
Just tell me what this was for.
I'm not telling you that.
Okay.
Hold your horses.
I'm antsy.
So anyway, here's the thing. We talked earlier about the demands on a manufacturer when they are creating aircraft parts.
You
for
said
instance,
hold
right?
your horse.
There's no faking or fudging measurements. You can't do it. You don't do it.
You don't do it or people die.
Right. If you do it, people die.
Yeah.
Right. If you do it, you'll get fired.
Tremendous consequences.
Tremendous consequences. Costs a lot of money. A lot of money. So basically, what they're saying is that I went into the Serapeum and I faked and fudged measurements, but because in other parts of the bottom, the precision seemed to fall off a little bit.
On the floor of this thing?
Yeah, near the floor of it. So there was it was obvious that, you know, that the box was not 100% throughout precise, but within, I don't know, the tolerance of that gauge or close to it.
Right.
So even if you say, okay, given that the gauge is 50 millionths, let's say that the accuracy of the surface is 1/2000th of an inch, which, you know, if it was, you would definitely see light coming through.
1/2000th of an inch.
Well, 1 or 2,000th of
Like
an
a
inch.
human hair?
It's like a human hair, the thickness of a human hair, which is fairly close. It's still extremely precise.
Yes.
And not what you would expect from a primitive culture or
No.
an underdeveloped industry or culture.
There's probably nothing in this room that's that precise.
Oh, no, there isn't.
Not even like a MacBook Pro or like a TV. Like, do you think that TV is 1/1,000,000th of an inch, or what was it, 1/1000th of an inch square?
I don't know, it could be.
Just tell me what this was for.
I'm not telling you that.
Okay.
Hold your horses.
I'm antsy.
So anyway, here's the thing.
It will be a pleasure to
We talked earlier about the demands on a manufacturer when they are creating aircraft parts, for instance, right? There's no faking or fudging measurements. You can't do it. You don't do it.
You don't do it or people die.
Right. If you do it, people die.
Yeah.
Right. If you do it, you'll get fired.
Tremendous consequences.
Tremendous consequences. Costs a lot of money. A lot of money. So basically, what they're saying is that I went into the Serapeum and I faked and fudged measurements, but because in other parts of the box they didn't find the same precision. Right. The two really don't compute. I'll tell you why. Okay? You go into any manufacturing plant. I could take you to the manufacturing plant that I worked at, and I could take you through the shop, and I could show you parts, and you'd look at them and you wouldn't recognize what was precise and what was not. Right? But I could say, okay, I'll point to a feature on the part and say, this is very precise. This area is not. But it's to the customer requirements.
Right.
Right?
Of course.
It's kind of like if you look at for instance, you look at a camshaft in an engine, right? you have the throws and you have the webs and the counterweights. Counterweights are forged.
Right.
Most times they don't machine the forging
Right.
for the throws for the counterweights, but they will machine the throws where the pistons are mounted to. Right. Those have to be precise.
Right.
So that's an example of a part that have non-precise areas and very precise
Yes.
areas.
Yes.
Also, even on a finished part, you may have different requirements for different areas of the part. You may have dimensions that have to be within 2/10,000ths of an inch. You may have dimensions that have to be within 10,000ths of an inch. All right. Just the fact that 10,000 of an inch variation from true form defines the whole part with respect to precision.
Right.
And do you ignore the 2/10,000ths of an inch precision that has been machined into it and say that the part is no good?
Right. Yeah, or like in an airplane, for example. All the little tiny parts inside of the turbine are probably extremely precise, but the joystick inside the cockpit probably is nowhere near.
Oh, well, that's comparing apples with, I don't know.
But it's all one thing, right?
Right, yeah.
It's a part of the
totally
airplane.
Yeah, I know.
I'm sorry, that was a bad analogy. I tried.
Yeah, but I'm talking about the same part. So
Okay.
we're looking at the
You're
same,
talking about one piece.
We're
Got it.
talking about the same part. All the features are integral, and they're contingent with the same material.
Okay, I
right?
see. Yeah.
Okay, so here we go.
We haven't talked about what the purpose of these boxes is yet.
Maybe they stole this from Japan.
You know what the purpose is. Oh, what my speculated purpose is. It's in my book.
Yeah, but this is a podcast. We need it from the horse's mouth. Can you tell the audience what your speculated purpose is? Or are you going to keep that secret? Or make them buy the book? If you want to make them buy the book, that's fair.
No, they don't have to buy the book. I mean, they can go to the library. Eventually, it'll end up in home.
Okay.
Oh, they can download a pirated copy from
Yep.
Google or
Yep.
like most people.
So you really want to say it?
That doesn't sound good.
It's not my theory, so I think
Whose theory is it?
Eric Wilson.
Eric Wilson.
Yeah.
Is he the aerospace engineer?
Yeah. He came up with a brilliant idea. We were down in the tunnels, 2018 or 19. And he came up with the idea that they were used for growing crystals.
The aerospace engineer thinks that the boxes were used to grow crystals.
Right.
How?
Good question. So, when you hear something like that, and it doesn't quite settle right away, I can tell it's not settling with you.
Not at all.
Not at all. You're like,
But
Right.
I can guarantee you I'm a lot dumber than him, so
yeah, that's pretty psychotic. No offense.
thanks.
So, yeah, and I thought that was an interesting idea.
What is this guy's
And I kind of
problem?
expanded on that in my book. But the other interesting thing is related to manufacturing, right? So you go through the tunnel, and you'll find boxes in different stages of manufacture. Some are roughed in, like they may have been created like that in a quarry before they were shipped, or they could have been loaded and worked on as they were in transit, or something like that. We don't know, but there's one box that's stuck down one of the tunnels that has a rough interior, but it's fairly regular in terms of its orthogonality, squareness. I mean, even though the surfaces are definitely rough, you can see that it probably may have maybe a half inch of material to remove to the final finish and dimensions. We don't know.
This
It's
is
just speculating.
This is evidence that those things would have been finished inside.
Yes, and I make that observation in the Giza Power Plant too.
Right.
Is that one of the things about granite is that it's affected by heat.
How so?
Oh, it'll move and change. Very sensitive to heat. When they finish a granite surface plate, actually, before they do, the manufacturer will rough machine a piece of granite, and then they'll store it outside. And they may finish it to within, maybe 5, 10,000 or a couple of thousand, I don't know. But it'll sit outside, and it may be out there for several seasons. And, it goes through hot season, cold season, hot season. So with every change in temperature, the granite changes. And before when they get an order for that size piece of granite, they'll bring it inside and let it normalize back to temperature. And it assumes the same precision that it was machined to before it was put outside in the yard. And then
Really?
yeah. So it has a kind of a memory. So they bring it in, and then they'll finish machine, lap it, and basically make sure, to whatever grade they're maintaining. So granite is very sensitive to heat. It's also sensitive to light, or at least we think it's sensitive to light. John Barter, who was a precision granite manufacturing resurfacer and calibrator, he has a company in Ohio. And I met him when I was working in Indianapolis, and we had a conversation about precision granite surface plates. And he was telling me about the one shop that he went into, and the piece of granite, the granite surface plate that they had, developed a crown in the middle of it. Come to find out, the reason why it had that slight crown in the center is because they had a single light bulb over the top of it. Right?
Wow.
Now, there's no information on how many watts that light bulb was, or how much heat. There's no real scientific analysis of why that was. But
Okay.
that was the conclusion. That it was because of that light bulb.
The light. How could we know how close that light bulb was to the granite surface?
No,
No.
don't know.
Okay.
But I just found that to be an interesting observation and
Yeah.
point to make.
Yeah.
And that even with regular tool steel, when you are creating precision artifacts to within tenths, right? 10,000 of an inch, 2/10,000 of an inch, you generally, temperature is your worst enemy, depending on the geometry of the piece that you are cutting. So if you are working on a very large ring and you're grinding an inside diameter or outside diameter, and you're working in a shop with the temperatures like 90 degrees or over 90 degrees, and then it goes into an inspection department where they're maintaining 68 degrees Fahrenheit temperature, it will shrink. right?
Right.
And generally, a lot of times they will, when you're grinding a block on a surface grinder, and you're measuring that block and comparing the dimension with a known gauge, like a Joe block. They call them Joe blocks. They're gauge blocks. But these are a collection of gauges that are like square pieces of metal of a specific thickness. They're hardened steel and very precisely ground to a standard of measure that is traceable back to the National Bureau of Standards. One of the techniques and tricks that you use when you're grinding something that you want to gauge it against one of those Joe blocks is you put the Joe block on the magnetic chuck on the surface plate as you are grinding the object that you want to measure against it. So what you're doing then is you are actually putting that Joe block in the same conditions of temperature as the object that you're grinding. So they are the same temperature.
Right.
So if there's any changes in the Joe block in terms of size, whether it's micron differences, when they are sent to the inspection department, then in like a 68-degree temperature, both the Joe block and the piece of steel that you just ground will reduce back to the correct size, so they can still be compared the same. Does that make sense?
Yeah, that makes sense.
Right.
Yeah.
And generally in a grinder you would run coolant on it, so you're actually flooding the Joe block at the same time you're flooding the piece that you're grinding.
Right. Right.
So yeah, finishing the boxes underground rather than outside would be necessary if your intention is to create extreme precision and hope that precision will remain and be put to use, right? Mm-hmm. So here's the other thing. I was thinking previously that the boxes were finished underground, but they weren't installed in the crypts. Now it seems that they install them in the crypt before they finish them, because you find unfinished boxes inside crypts and semi-finished, right? So
Okay.
you got three stages of manufacturing. You got the rough finish, forge finish, or cast finish, quarry finish. Then rough machining, where material is removed to bring it closer to the final dimensions, and then final finishes where the final accuracy is cut into it.
It becomes reflected.
Yeah. So
Go ahead.
So that's one thing, that finishing those boxes to that precision and then making sure that they stay precise is an objective. They seem to be accommodating by doing them in situ.
Right. So going back to the crystals, how would they have grown crystals inside of those boxes? Does he speculate? And for what purpose?
He didn't elaborate on that, but I did in my book. But it's where you kind of have to stretch your imagination a little bit.
Okay.
Right.
I'm always open to stretching my imagination.
Right. Do you ever read Engines of Creation?
No.
Oh, it's a great book.
I'll write it down, make a note.
No, seriously, it is very futuristic.
I love that.
We are not there yet. Definitely not there yet.
It's a wild, out there, futuristic sci-fi theory.
It's super sci-fi, super wild, and you think about going out on a limb and having it chopped behind you while you're out there. This is one of those times when I'm feeling like I'm way out on a limb.
So you think by talking about this out there theory that people will be able to use that to discredit you for your other work?
Oh, like I'm not already discredited.
Right, exactly.
Right, yeah, I mean, my enemies will love it. They will, oh my God, it'll be like feeding them red meat.
So were these crystals used for the solid-state electron harvester pyramid?
Well, it's hard to say. I would say that there are more futuristic and advanced applications for the process if you can develop it. And that is the crystal growth of rocket engines, jet engines, advanced materials, using nanotechnology.
This guy's weird.
The crystal growth of rocket engines, jet engines, and nanotechnology.
Using nanotechnology.
Using
Yeah,
nanotechnology.
Drexler talks about what he calls them universal assemblies. These are nano machines, right?
Now.
That assemble products one atom at a time. And so basically they are used he said that using this technology in the future, you could grow a rocket engine that would have like 10% of the mass of a current rocket engine.
You could grow it.
Grow it, yeah.
Okay. I have no fundamental baseline idea of where this is even coming from. We're not even talking like quantum computers or anything here. We're on another limb. Whole other branch.
Yeah. So when you look at the boxes in Serapeum and you're looking on the inside of the boxes, you have the upper part of the box which is fairly flat. Right? On the side of the lid, it's fairly flat. You got specific dimensions. They may vary a little bit, but essentially, you could look at that assembly, one of the boxes, with a lid on top, as a Cartesian coordinate system.
A Cartesian coordinate system.
Yeah.
What is that?
Well, that's where you have a precise location to reference when you are in three-dimensional space.
Okay.
You got your X, Y, and your Z.
Right.
And so if you know where you need to be in that three-dimensional space, and you can reference a precise surface in that three-dimensional space, or three surfaces, then you can figure out where you are in three-dimensional space.
Three surfaces.
Yeah, X, Y, Z. So, but you've got.
That means you would need six surfaces, though, right?
You got five surfaces to work from. Yeah.
Wouldn't you need top, bottom, left,
Don't
right,
need
front,
bottom.
back?
Don't need bottom.
Why don't you need bottom?
Top defines a Z. it's science fiction. You know, you could take the book as being a a futuristic science fiction look at the future, because one of the things that I do discuss in the book is the the validation of the UAP and the these craft that perform amazing miracles of flight.
Yeah, what's more science fiction than that?
Yeah, what's more science? But that is real. That's happening in
Exactly.
space, right? And
But 10 years ago, you'd be laughed out of a room for talking about that
you would
on a TV show.
Definitely, I wouldn't talk about it. I never talk about UFOs,
Right.
ever. But when you see that kind of performance in our airspace, and not just in America but other countries around the world, it's like okay, something. It is possible
Mommy said
that
not to
civilization will
ride with
develop to the point
anymore.
where we could match that performance, right? And have craft that perform in a similar manner. But we've got a lot of discovery to make. Right? We need to be able to control gravity. We need to have an alternate system for propulsion. You don't see afterburners kicking in on those jets on those tic-tacs when they shoot off at impossible speeds and turn on a dime, right?
But the interesting thing about that is too, the recent evidence that has come out points to the fact that dark programs within the U.S. government have been working on this since the 30s. So, if you take the fact that they've been keeping it secret, if they have been, since the 30s, not keeping it in public, like keeping it dark, if they were to look into something like the pyramids and the possibility of the Great Pyramid being a solid-state electron harvester, wouldn't they keep that dark too? I doubt they would keep that in the public. They would not keep that research open source.
I mean, all those are unknown, and I hear lots of speculation, conspiracy theories, and I just have to ignore them, really, because there's no answer to it right now. It's just like the UFOs, I mean, they were largely discounted and ignored, and so then the governments suddenly woke up to the fact that, hey, these things exist, and then they have hearings on Capitol Hill about them, and, it's like, wow, times are changing. It's like there's a huge shift.
Right. Right. But the thing, like, to be able to get to where you've got, to get as far as you got with your theory on the Giza power plant, harvesting electrons from the igneous rock underneath the Earth and being a massive free energy generator, you can't start at that. You have to start in a science fiction world first, and then you start with a big granite block, and you have to chisel away your statue to figure out and test it against different things to figure out the real life possibilities of it, or the real practical implications of what that would be and the way that we would put that to use on Earth. Right? You can't just start with the answer. So when you say that, yeah, right, like the same thing with the UFO.
No, you're absolutely right. I mean, everything needs to. I mean, all the subsystems need to be built and checked out and perfected. I mean, there is definitely strong indication and evidence on the Giza Plateau that when they designed and built the King's Chamber, they tested it out before it was installed in the Great Pyramid. So the technology that they installed was tested outside the Great Pyramid. They have what they call these trial passages on the east of the Great Pyramid. Basically, what they have is like the beginning of a grand gallery, right? There's a descending passage and then a vertical shaft that goes to the bottom of a grand gallery that goes up, and then it comes out the open. And so when you look at those trial passages, the same dimensions that you find inside the Great Pyramid, they were measured by William Flinders Petrie, and they're in his book, Pyramids and Temples of Giza. So when you consider any kind of development on technology, you prove out each system and subsystem before you put them together. So there are some things that are fairly well known and simple, such as the creation of hydrogen. But the function of the Great Pyramid and the balance and tuning of all that granite to work harmoniously and in resonance with input vibrations, that's something that you would want to test out and tweak.
Right. Let's talk about the Petrie core.
You want to do that?
Yeah. Now, you were the first.
You leaving the worst to last.
You were one of the first people to get your hands on this Petrie core and measure out the grooves around the edge of it and run a string along it and determine that it was actually a spiral groove, not just horizontal grooves.
No, actually, William Flinders Petrie was the first.
Right. Duh.
No.
I thought it was called Chris Dunn's core number 7.
Yeah, no, it's not. Petrie core number 7. Yeah, I really caused a stir with that, didn't I? So I was writing the Giza power plant, and like I said earlier, a friend of mine recommended that I submit an article to Analog Magazine, which I did, and it was published in '84. So that was called Advanced Machining in Ancient Egypt. And in that article, I referenced the Petrie core and relayed what Petrie wrote about it. That it was a tapered core, came out of a hole, presumably, that exists in the Valley Temple, and that it had a spiral groove. The grooves were 100,000 distance apart, and that he checked like 4 turns of it, and claimed that it was a true spiral. And he also said that the groove was cut deeper in the quartz as it was the feldspar. Okay. So when I was trying to figure out, using my machinist tool-making background, what kind of technology could create those kind of features,
right,
I proposed that perhaps they had used ultrasonic machining, because ultrasonic machining is not, it's not like a conventional type machining where, conventional drilling of granite, as I learned from an ultrasonic, or a conventional granite manufacturer, Ron Granite in Ohio. Conventional drilling holes, the penetration rate was like 2/10,000ths of an inch per revolution of the drill.
2/10,000ths of an inch per revolution.
So if you look at 100,000ths per revolution, that's like 500 times greater than the conventional drill.
Okay.
It's an impossible feed rate in granite.
And you can figure out the rate by the distance between the grooves?
Yes.
Okay.
Right. And that's where the controversy began, is that I proposed a method that was totally unacceptable, ultrasonic drilling, which is where you use vibration to impact the granite and remove material, and then advanced the tool into the granite using a screw and nut method, as you can see there with the capstone at the top. And you just put pressure on it, moving it into the granite. use a slurry, which will actually do the cutting. And then there's a taper on the bore and the outside of the tube drill. And that taper, the tube drill will wear as it is penetrating the granite, and that is reflected on the core and the hole as a taper. Right. So that was just a simple idea. It received limited attention after the article was published. There was a couple of protests, one by L. Sprague de Camp, who objected to it. He wrote a book called The Ancient Engineers, and so he claimed that the working of stone by the Egyptians is well known. Went through the whole list of copper tubes and fashioned stones and stuff like that. I responded to his email, and then that was pretty much it. And then in 1995, I was invited to participate in a message board discussion on Deja News, and there was a guy called Rodney Small who had read my article in '84, and evidently had become a point of discussion on the Deja News archaeology message board. So I joined in, and that was my first taste of message board discussions. And and so after, I don't know, maybe 1,000 or so posts, it kind of petered out. I don't think anybody changed their position on
This
it.
was what year, roughly?
1995, I think.
Ooh.
Yeah.
You got mail.
You've got mail, right? Yeah, the old key.
Yeah. That was before that, probably.
No, it was actually 95 when I first got online.
Oh, was it really?
Yeah.
Oh, wow.
Yeah. Yeah, so I was on AOL. I'm still on AOL.
Are you really?
I know people look at me strange like that when I say that. Yeah, I'm still
Good
on
for you.
AOL. Still have the same email.
Still holding strong.
I don't know about strong. Holding.
Okay.
All right. So then, after that, there was a book published by Chris Ogilvy Harold and a guy called Lawson. I forgot his first name. I'll think of it. So anyway, they wrote a book called The Keys of the Truth, and in that book they report on an examination of the core by two people, Reed and Brownlee, who go to the Peter Museum where the core is located, and they determined that it's not a spiral, that it's a horizontal groove. Okay. So I looked at that, I read that, and I was like, well, okay, interesting. But it looks like the core is slightly tilted, and that would kind of throw you off when you're trying to visualize the core, the spirals. And so I was still on Petrie's side, but I was willing to the groove and run, right? But not just with that photograph. So knowing where the core was, I arranged to go to the Petrie Museum and inspect it myself. And so I went to the Petrie Museum, and I wrapped a thread around the core. So I righted the core. You can see it tilted on the left in the same way that the book shows it. And then on the right, I squared it up to the frame. Right. And then in my book, I included this, which is a common pipe thread. It shows you how just a slight tilt on a pipe thread, you can turn a spiral into a horizontal very easily. It doesn't take much movement, right? Simple.
Very simple.
All right. So there I am at the Petrie Museum, and there I am with my thread. And I found, well, it's a spiral. Okay, so
You followed it the whole way.
yeah, followed it the whole way. So I reported on that, and on my website and in message boards, I reported on it. And then I had, kind of, no, we don't believe you. You guys could be playing tricks with you, and probably confirmation bias comes into play, where you are controlling, you're more in control of where the where the thread goes than the group. And I'm like, well, no, that's not the case, but okay, that's the way you feel. So there was another time that came up, and this was in 2003, actually. Yeah, 2003, and it was with a man had contacted me. His name was Malcolm McClure. He's a geologist, and he was retired from British Petroleum. And so he contacted me and said, there's a lot of mysteries discussed, and there's still two that I haven't quite got figured out. And one of them is crop circles, and the other one is the Petrie core number 7. I was like, yes, I haven't figured the crop circles out either. So
That's right. You're on the pyramids. You got your hands full.
right. And so he said, and I said, well, we could take a trip to the Petrie Museum if you like, and I would join you because I'm getting a lot of pushback on my observations. It would be good to have somebody along to do a check themselves. And he said, sure, that'd be great. So he made arrangements with the museum, because what I wanted to do at the same time, I wanted to have a latex impression made of the outside of the core. Right.
And you guys did this. You guys both wrapped the core with the string. You guys both found that it was a spiral groove.
Right.
Took video, took pictures.
Right. So he said, well, it would be good if maybe we could just take photographs at different angles around the core, and then just stitch everything together and see what we get.
Too primitive.
And I said, well, okay, so this is what he sent me after he had stitched his photographs together.
Yeah, it doesn't work.
And it's like, okay, yeah, I don't think that's not a valid inspection method. For a mechanical, I mean, I would think that would be normal for a geologist to display a core out of the earth in this manner, so that they could study it and compare the entire circumference of it.
Right here, you see, this is copied again right here. But I guess you have to do that to line up the grooves.
Yeah,
You have to copy it, so it gets confusing.
That's very confusing. So if you recall, we talked about the use of cones inside jet engines.
Yeah.
One of the techniques that is used for creating cones, say you are creating a state or something like that. In the old days, or maybe even today, they would create a flat blank and apply geometry to it. A manufacturing engineer would get a drawing, and it would show the cone in assembly and as a detail, and it would have a series of holes that were cut on the outside. Those holes may be airfoil shaped, or they may be round. And then the engineer would actually unwrap that cone to make a flat blank. And so by making the flat blank, in the process of unwrapping it, the geometry of the holes that penetrate it change dimension. Because as you're looking at it in 2D, right, you're looking at a geometric feature on a cone in 2D, it's wrapping around in three-dimensional space, right? X, Y, Z. So when you unwrap it so it's flat, then it changes shape, changes dimension, right? So that is a common thing that was done.
Okay.
So if you look at a frustum of a cone, you got a 2D drawing of a frustum, you see horizontal lines straight across, right? That's just a regular 2D. Now, when you wrap a cone and you look at the frustum as a 3D surface, and your focus is on one of those lines, it will appear horizontal. But the lines above and below will begin to curve as the angle of the ramp, the direction of the camp. So you'll have a radius at the top and a radius at the bottom. Right? Those things happen too. Okay, so there you go. After we inspected it, we went to see the director of the museum.
Mr. Mold right there.
A very nice fellow, Dr. Stephen Quirky. And I asked him if it would be possible to have a latex impression made. And so, I paid him the required amount to have it done, and he had it done and sent it to me. So there it is. The latex is split at the ends, so what I did is I actually created two reference holes. There were those squares that were cut in, and then I cut the line between them.
Okay.
Right? So the objective was to lay it out flat, and then inspect the lines to see if they were horizontal or spiral.
Okay.
So the horizontal groove would start at one place and end at the other place, right? Start at the same place.
Yes, exactly.
Right, so...
I see. It's not ending, it's ending lower.
I mean, it's flat, but it's ending where it started.
So it's spiral.
If it's spiral, then it's not going to end at the same location that it starts.
Right.
Right? Make sense? So then I laid out the flat blank, I squared it up, and I started to see the general kind of sweep of the arc. And...
Yep.
I mean, you can stare at that for an hour.
The right side of the line is higher than the left side of the line.
Exactly. Right.
So it is a spiral.
So it is a spiral.
That means this thing was cored out of a piece of granite using one of these. What are the machines called again? It was a machine.
Yeah, it was some kind of technology. Really, I don't think it was ultrasonics. I backed off on that.
You backed off on. You don't think it was ultrasonics,
right? Because of some of the other features on the cone.
But it was a machine.
Well, it would. Yeah, I mean, they were employing a technology. They certainly wasn't done with a copper tube and quartz sand.
Right. Absolutely not.
Because you won't get those penetration rates, right?
Now, what about the edges of the grooves? You mentioned that they were very smooth. Was that because they're not very sharp grooves? Now, is that just weathering and like thousands of years of degradation?
You know, the thing is that it's really, really unusual. The features on it are bizarre, really, and. Yeah, and it's forgivable to be a little confused by what you're looking at. So when you look at a 10 power close-up of the grooves on the latex, you can see where there's all kinds of variations and stuff going on. There are runs between the grooves that are almost vertical in places. Some at 45 degrees. You know, I mean, it's kind of like this area right here, this one right here, this one right here, that one here. Yeah. And so it's kind of like it's a mess. And making sense of it is very difficult, right?
It's chaos.
Chaos. So how do you sort it out?
Right.
I mean, and then, of course, the work that is cited for the true method that was supposedly used to create these is Dennis Stocks, who did some experiments. And he wrote a report in his book and also some articles that he'd written that the horizontal striations were similar to the ancient ones on Rose granite. But he does not, anywhere in his book or articles, he does not talk about Petrie core number 7, nor does he display an image of Petrie core number 7. Right? He ignores it completely. But he says they're horizontal. And that's what people are relying on, is Dennis Stocks' testimony.
Okay.
Right? Because it fits their narrative. The other thing was, I emailed Dennis, and I asked him if he had a clearer picture of his core that I could have, because the one in his book is not very clear, and I was wondering if he could send me a clearer picture. And he basically said, no, he's not going to send me.
Oh, wow.
And, just make your own. So I did.
That's rude.
Yeah, no, I won't say. Yeah, he was just, I don't think he likes me. I don't blame him.
So going back to the smoothness of it, do you think there's any evidence that the stone was heated up and made softer?
You see, that I think, as a preliminary matter, is the first thing that you think about when you look at a polished surface. Is that how did it become polished? Was it through polishing? Was it through? It certainly was not through grinding with sand and copper. Right. Because that's the core that I made, and to the right of it is the core that Dennis Stocks made, and those surfaces are not polished. Right.
Right.
So then the question becomes, how did the Petrie core receive its polish?
Right.
And considering that you do have those weird runs from one of the grooves to the next, it seems like it's a really not precise, I would say, but really quick and dirty way to sink a hole in the granite. And it may have involved a means of softening the stone, maybe even melting it locally.
That's the first thing I thought of when I saw this.
Really?
When Ben showed me these vases for the first time, I thought that they had been melted and thrown on a wheel. Because that's what it looks like, right? It looks perfectly symmetrical. It is perfectly symmetrical.
Well, I mean, it was on a wheel, for sure. Maybe not melted, though. I don't know. Are we talking about this now, or are you ADD?
No, we're still on the core. So we're talking about, they could have been heated up or possibly melted at that spot.
Right, yeah. Are you ADD?
No, we're still...
Sure.
Maybe that's what it looks like, right? It me these vases for the first time. I thought that they had been melted and thrown. I thought of when I saw this.
It may have involved a means of softening the stone, maybe even melting it locally.
That's the first thing I thought of when I saw this. When Ben showed me these vases for the first time, I thought that they had been melted and thrown on a wheel. Because that's what it looks like, right? It looks perfectly symmetrical. It is perfectly symmetrical.
Well, I mean, it was on a wheel, for sure. Maybe not melted, though. I I don't know. Are we talking about this now, or are you got ADD?
No,
something?
we're still on the core. So we're talking about, okay, they could have been heated up or possibly melted.
Dude, this guy is. Oh my god. Oh my god. Oh my god.
At that spot.
Right. Yeah. Okay. Well, and there's a hole, the upper right. That's the hole in the Valley Temple that they speculate it came from. There's no way to know for sure
Wow.
whether that's the one. But that's the hole that I made and the core that came out of it on the bottom. Right.
Wow.
Okay. So then there was an article published by a Russian research group, and they had done kind of like a debunking article on my work and Petrie's work, and they had essentially photographed the core at various places around it and then stitched it together and came up with a surface and grooves that looked like that.
Okay.
So this was performed by a professional geologist and mineralogist, P. Selivanov. The article is, you can actually Google 7th of Petrie rather than copying that URL into your search bar.
Yeah.
But you'll be able to read the whole thing.
Okay.
So here's the thing. It's like, okay, I totally get why a geologist would want to examine a piece like that. This was featured on a video by a YouTube channel called Scientists Against Myth.
Okay.
Right? And so anyway, the interesting thing is now, up to now, we had my first examination, which is a spiral, and then Malcolm McClure, who checked it with a thread and found it was a spiral, and then Eric Wilson visited the museum, and
He's a crystal guy.
he's a crystal guy. He's the aerospace engineer.
What is he? Does he work for a big aerospace company?
Yes, a very big one.
Oh, really?
Yes.
Which one? Can you say or no? Would that ruin his job? Would he get fired? Eric, you're talking about crystals. You're fired. Sorry.
Well, let's say the headquarters are in England. And he was visiting, so he went to the Petrie.
Why does it focus on that? It's so strange. Google. Hey Google. How many days has it been since August 29th?
August 29th, 2023 was 7.
Museum while he was there.
Oh,
For
okay.
work, yeah.
Wow.
Well,
We have a video of it. Oh, you got the video here. Oh, let's transfer to Steven's computer so we can play this video.
I had the opportunity to go to London, and I had some time, and I wanted to go to the British Museum there, and the Petrie Museum, and I learned from you actually that you can't get into the Petrie Museum to see the good stuff, the Petrie core and specific artifacts, unless you fill out a request form.
but you also have to be credentialed too, right?
You have to have a reason. You can't just walk in off the street and request pieces from the archive.
Right.
You have to have credentials. Yeah, you have to be. You can be a historian, or you can be an engineer.
Knowing the controversy that was surrounded the Petrie core,
It's like an interrogation video.
you designed an experiment when you got there to determine whether the Petrie core was a horizontal groove or
we
if
did.
it was spiral.
First, it requires more than just your eye. You need to have some optics. Some high-powered readers seem to work the best. I actually had a jeweler's set with lights, that you could really get down into you can see the material structure. And then we took a thread and rotated and wrapped around the groove, and it was definitely a spiral. It wasn't just me. It was my colleague. I'll mention his name, Josh Gear, also aerospace engineer. We both witnessed and wrapped that groove. So
You think, and you consider that to be a legitimate methodology for determining whether it's a spiral or?
yeah, I mean we rotated. What's my picture got? It's probably got 20 wraps.
Yeah.
I mean, there's 20 observations. Every time you come around, you
Okay, so
cross.
airspace confirms that it is a spiral.
After a dozen wraps, they were not crossing.
So
Show the picture.
yes, that's a.
Eric Wilson's putting me to sleep. But yeah, no, I mean, it's
He's an engineer.
yeah, he's an engineer.
Gotta have respect.
Well, it's clear. I mean, I don't think I couldn't imagine anyone could come up with any sort of real argument against this. All the stuff that you guys have done to prove it, that no one's disproven it, right?
Well, you've got two aerospace engineers, you've got a manufacturing engineer, and you've got a geologist.
Let's show the vase so your son was a big part of making this vase, right?
The base belongs to a gentleman from New York. His name is Adam Young, and he and Alex met in Egypt and became good friends. Adam was talking about the collection that he had, and he had several of these what we call pre-dynastic vases.
Right.
All right. Alex, they set up a time to meet in Indianapolis at a company that Alex was working at that time. They were a defense contractor. And he brought his vases and we did some mechanical inspection on them on the surface plate with a rotary table and indicators to check roundness and flatness and stuff like that.
Right.
So I was in attendance at the time, and it was like, yeah, this is interesting. It kind of looks like an Egyptian vase, but because it was bought on the antiquities market, there was always in the back of my mind there was a question of provenance that might be an issue with it. But anyway, Alex was passionate about it. He suggested that they have it scanned, structured white light scanning, which they did at a company called Capture 3D.
And for people that are curious about seeing those images, we did that with Ben. He showed all the slides and all the measurements and everything.
You're all up to date then. Yeah. So essentially, that was the path that took. And then they went on Ben's program, and the STL was made available to a lot of really interested engineers around the world. And
that's cool. They open sourced it.
And then there was this one guy in Spain, he's from Denmark, I think, named Mark Vist, that he did a mathematical analysis and then wrote a paper about it, which was unbelievable. So there are many interesting features about that base, and I'm sure Ben covered it in great detail.
These had to have been made on a computer.
Well, that was the conclusion. I've always been a little more reserved than that, but I'm not looking
You're
at it.
reserved? The guy who says the pyramid was a solid-state electron harvester?
That's a pretty conservative estimate. Could be even more.
Is that more?
sophisticated than
What's
that.
more conservative, that or the fact that this was made on a computer? That is the question.
I guess I win on that. I mean, it all just doesn't fit with the current narrative.
Right.
And
Well, hopefully stuff like this will blow that out of the water.
well, the thing with this is that okay, admit it, provenance is a huge issue with this, and it left Egypt, and it's had in a collection. Some oligarch somewhere may have had it in a collection, and he died, and his heirs sold it to an antiquities dealer, and then Adam bought it. So provenance is an issue. The thing about it, though, is that there is one particular feature that I found I connected with. It was it is like an ellipsoid. The body of it matches an ellipsoid, right? And if you read my book, Lost Technologies of Ancient Egypt, I look at the statuary in Egypt and the use of ellipsoids on many of them, particularly the crowns. And so that was a huge thing for me. But the precision it's kind of beyond belief, considering it's like cutting granite. And I'm reading comments on Ben's channel and that machine. I'm a 25-year machinist. We couldn't do that today, and blah blah blah. And he's like, well, we need to find somebody who thinks they can do it, and have them give us a quote. So I think that is still an option that we're examining. But ultimately, the real objective is to say, okay, Egyptian engineers, There's some of these in your museums in Cairo. So we encourage you to take the same steps we did and do a metrology examination of them
Yep.
on artifacts that have known provenance, and then all the naysayers and debunkers can go to bed.
Yep. Well, Chris, thank you. I really appreciate you coming through and spending 6.5 hours here with me and talking about all this stuff and your decades of research. It's truly an honor. Where can people find your books? Are they on Amazon?
Yeah, Amazon,
Your website?
all the online bookstores and
Perfect.
brick and mortar bookstores.
And what's your website called? Gizapower?
GizaPower.com.
Perfect.
Yeah, under construction.
All right. That's it, folks. Thanks again, Chris.
You're welcome, sir.
Good night, everybody.
Good night.
Why doesn't it focus, bro? What the fuck?
For determining whether it's a spiral.
I'm the Avatar. You gotta deal with it.
This is the very first scene in Legend of Korra, and god damn do people not like this scene. The main gripe with it is that Korra doesn't get to have the same journey as Aang did when learning the elements. Instead, she can already bend 3 elements at the age of around 5. This is one of those moments in the show that I feel like I have to excuse for the fact that Legend of Korra got 12 episodes to world build, set up a plot, hit a climax, and a resolution with one plot line. The Last Airbender had 60 episodes to achieve that. So while I agree that this scene isn't the strongest in Korra, I don't think it really hurts the series overall because we gotta get this shit done. They don't have time to show her learning all 3 elements. Give Legend of Korra the same 20 episodes per season, and we'd be hearing much different opinions about the series. If you want to watch more Legend of Korra based content,
True.
Z30 testing on board the core button just before the Z30 is so much more than that, and I'm going to cover more videos and break down bits in other videos as well to show you what you're capable of doing with the Z30. But we're specifically looking at the autofocus. Now I'm recording the screen via another camera because unfortunately
I cannot record the screen with the dirty HDMI out. For some reason, the Z30 does not allow that, but that's because there's no AVF electronic viewfinder, so I cannot record that, but it's not allowing us to record the compact light, and it really is with a 112 Google frame. If your lit is on the Z6 as well, especially for autofocus, and if you want to kind of rack focus, or just select your camera to focus something else in the frame, you've literally just got to touch the screen, and that's how easy it is. Nikkor 60-50mm is an absolute diamond of a lens, kit lens to be fair. It's a cracking vlogging lens as well. I just kind of like a little bit more shallow depth of field, so I'll probably go with maybe a 1.8 prime lens, maybe the Viltrox 30mm that's going to be coming out. I think that'll make a great addition to this APS-C camera. We'll make on you actually hear. We'll probably use because it's actually 0.4. The only downside to this lens is that actually you can hear the autofocusing really loud. If I move, I'll demonstrate that. You probably hear that with the shotgun mic. If you wear the pen mic, you actually can't hear that at all, and that's what I've been doing for quite some time now. So, with it being a vlogging camera, I probably want to set up the shotgun mic on because I like the sound of the Rode Mic Pro. And if it's the same distance away all the time, you want to get the same quality of audio as well. But that's with the Sigma 8 35mm 1.8. A little bit of a bonus there for you guys. It's a fun tool, easy to big up. The tool come out the do as well. With it being you probably hear that with the shotgun mic. If you wear the pen mic, you actually can't hear that at all, and that's what I've been doing for quite some time now. So, say this small body Sigma 8. So,
So in this video, guys, I'm gonna do it super straight. And right now, I have the autofocus settings to the highest speed, as well as a level 7 sensitivity. And as you can see right now, we are in video mode, and there is eye autofocus, which is why it was unnecessary for me. As you can see, I put my Blue Yeti here, and we'll see how sensitive can it still track my eye. So right now, as you can see, it is tracking my eye completely fine. I turn off the backlight to just see if there's more contrast, so the autofocus will hopefully work better. But I'm gonna raise my mic up. Let's see, pop his face. Oh, be that I use. So I don't using the kit lens tracking me. Eye priority turn on in the autofocus system. Focusing on. I do not lose focus. Eye moving. Still on. You can switch. So let's see if we're all that great. And body more better. Almost left. But what I'm wondering is if I actually turn off the light here, my key light, that's my hip, it's still tracking me, right? With and I'm gonna keep it far. So I'll be taking right here. Go into so in order for you to go to the proper settings, what you want to do is go to menu, go into this pencil icon, go all the way down to video, and you start to see my autofocus speed is actually at 5 right here. It's the fastest. Go back, okay, and my sensitivity is at 3, where 1 is the highest, 7 is the lowest. So if you watch this far, you're watching Broke Vision Collective. My name is Peter. And
still not working.